Group. Yeah. All right, sweet. Well, what's going on, everybody? My name's Daryl Roberts. I'm the head of AI at a local AI company called Omni AI. We're doing lots of really cool things in AI. My background spans across data science, where eventually I made my transition into computer vision, working on projects like dental reconstruction in the 3D space, self-driving forklifts, things along those lines, as well as 3D printing for concrete houses. Eventually, with this big boom in LLMs like ChatGPT and Claude and all of those things, I found that I can't really get away from agents. They're not really going anywhere. So these days, I'm working mostly with LLMs on a daily basis, and I wanted to share, our design philosophy whenever we're approaching these things. Because when it comes down to it, these AI systems are still a discipline of data science, and they've allowed for some. Oh, it's too loud. Okay. Oh, yeah. I do talk very fast, so hopefully I don't lose you guys. If I do, just be like, hey, slow down, man. But yeah, so it is our design philosophy for designing AI systems in a smart way that you can actually trust them. So let's go. I guess I have to be on this screen. All right. So first things first, do we have any veterans in the building? All right, we got one. All right, so happy early Veterans Day. That's it. So happy early Veterans Day. I myself was in the Marine Corps for 6 years. So very big part of who I am, and more importantly, tomorrow is the Marine Corps birthday, 1775 Ton Tavern. So it's our birthday tomorrow. So hoorah, Devils. So in a very Marine Corps fashion, let's get off of that. In a very Marine Corps fashion, there is this decision matrix in the Marine Corps called the OODA loop. So what the OODA loop is it's a principle for making quick decisions. So it was founded by Colonel John Boyd, who developed this decision-making framework in order to help with fighter pilots, and it has become fundamental in how Marines think about rapid decision cycles. In the same tradition, on the back of the OODA loop, we have our AI engineering loop. So that AI engineering loop looks a bit like this. So you want to express your intent to the actual model. So what's your data look like? How are you expressing that data? What do your prompts look like? Your processes and your logic. And we'll get into that here. But the general shape is we're going to express intent. We're going to allow our models to execute on that intent. We're going to observe the results, and then we're going to adapt our models and improve them. So here's a common pattern that we see a lot in, if I can say anecdotally, in consulting. We're seeing this sort of pattern that companies are adopting that's just the React plus MCP recipe. Do we have anybody familiar with React or what it is? Yeah, so it's the pretty common cycle. A lot of the big companies are kind of using it just because you can kind of throw it together and say go, right? So it's reason and act. Essentially, your AI is going to take a whole ton of tools. You're going to give it a toolbox of like tens of 20s of 50s of tools, and give it some task and hope that it can carry that task out. And most of the time it can't. And you're given sort of something where you're thinking like, this thing just doesn't work, right? So MIT did a study. They found that 95% of AI startups are actually failing. So we want to understand why is that. So the statistic's quite staggering. It highlights that there's probably some common missteps happening in the AI world. We see that React is just a recipe for failure. They typically are choosing some powerful general model like a GPT-5 or a Claude Sonnet 4.5. They're going to give it a ton of MCP tools or ChatGPT assistants with their own internal tools. They're going to just let it do that React pattern, reason, act, observe, repeat. And then they're going to build an app around it, and they're going to ship it and say that they have some magical AI application, right? So sounds familiar, but React won't be a winner. Here's why. It abstracts away your entire AI layer. You have absolutely no idea what's happening, and you have no idea of how to fix it. So what happens when things go wrong? So you see that you basically have three options. You can improve your input prompt and hope that it works this time. You can try a different model and hope it does better. You can add more tools and hope for the best. And then you get a new result and you hope it's right. So you notice a pattern across all of these options. It's hope. It's not engineering. You have no control over the reasoning logic, which is hidden. You have no control over the query decomposition, which again is hidden. The search tasks are opaque. Your tool call decisions are uncontrollable. Your context compression is invisible. Everything is happening behind the scenes, and they're doing it for you and saying, "I swear I'm doing a very good job," and buy my product, right? So you say, if my thing's not doing well, if my application's not doing well, then that just means that the model can't do the job, or this MCP server isn't good enough, and now you're stuck until something better comes out. You've abstracted away your entire AI layer. You have no levers to pull, no knobs to turn, and no systematic way to improve it. Then we see a fine-tuning rush, where a company says, okay, well, it's not doing the job right. I have terabytes of data. I'm just going to fine-tune my own model, right? Typically, when we come into a situation like that, the first question I ask is like, what have you tried? Why have you decided that fine-tuning is necessary? What are your metrics? What is your faithfulness metric, your context recall, context precision, et cetera? How did the pre-built models perform? How well-defined is your workflow? Is your data even ready for fine-tuning? Have you tested simpler approaches like better prompting, few-shotting, or retrieval? Fine-tuning, we find, is the most time-consuming and the most expensive operation that you could possibly run on AI, especially on these much larger models. If we're going to fine-tune, we want to be 100% sure that it's necessary, and we want to be 100% sure that the data is quality. But most teams jump to it because they don't have a systematic framework of improvement, and they don't know what else to try. So we're no longer in this era of data science where we see an AI problem, we collect a massive training data set, we build a neural network, we tune the activation function, the learning rates, the hyperparameters, or even gradient descent. We're not training from scratch anymore. But this has led to irresponsibility. So teams think that, just throw GPT-4 at it and it'll figure it out. Prompts are easy, anyone can write them, and we don't need machine learning engineers anymore. This is wrong. So at the end of the day, this is still a data science discipline, and these probabilistic models still need to be tested for if they solve your problem. They still need to be measured as far as what does success look like for you. They need to be quantified, and they need to be improved. You can't improve what you don't measure, and you can't measure without a plan. So we introduce our loop framework, our AI engineering loop, where we have express intent, execute plan, observe your results, and adapt. So you notice that the loop closes between adapt and express. And this is because the better your system is adapting to your data, the better it is that you're able to express what is your intent. It's able to do the job more reliably. You get better specifying you get better at specifying your intent based on what you observe and what you measure. And this is the loop that separates engineering from consumption. So that's sort of the separate, right? So you have AI engineers that are doing loops like this and improving models, and then you have API consumers, which are essentially just doing express, where they say, I want my AI app to do this thing. They do execute, where they say, I want a model that's good at doing that thing, and then they release it, right? So they don't do anything else. So that's sort of what separates us. They just kind of pray to the AI gods above that it's going to work. Organizations that execute this loop systematically will dominate. Those that don't will likely be part of that 95%. So express is more than prompts. Express is how you specify your intent, and your intent can be consolidated in many different ways, right? So it's more than just writing a good prompt. That's part of it, but expressing is much broader. It includes your data preparation, so your parsing strategy, your chunking strategy, cleaning and metadata. It includes your architecture design. Are you using RAG? Are you using agents or something hybrid? What is your process flow? So are you doing multi-step reasoning? What's your tool orchestration look like? And intent specification. I will preach DSPy until the day I die or until something better comes out, so I'm a DSPy shill. But DSPI signatures give us the ability to go back to engineering and less prompt hacking. So just because there's a new shiny tool doesn't mean that you need it. So data preparation, parsing is how you actually express or show that your data or what shape you want your data to be in. So you may make the choice that maybe Markdown's doing best for your use case. In some cases, maybe HTML's doing best. So you decide, I'm going to parse everything to Markdown. I'm going to use PyMove PDF for LLM. And it's performing better than plain text extraction. Just remember at this step, garbage in, garbage out. So parsing quality determines everything. Chunking. So chunking is how you say, okay, what is a meaningful unit of information for me? So the trade-off is, larger chunks have a tendency to come back more accurately, so you have a better recall. But the larger your chunk, the larger your context window, so your precision's lower as well. So you have that trade-off that you're trying to measure. Then techniques. Are you going to do fixed size chunking? Are you going to do recursive text splitting? Are you going to go towards something more difficult to set up like semantic text splitting or even agentic text splitting? Our surprise on this one that I'm kind of mentioning here is after running all of these things and setting up semantic text splitters and agentic text splitters, at the end of the day, we got best context and recall precision if we just said take the whole page, right? And we wouldn't have known that if we weren't measuring it. And then cleaning. So you need to clean out your HTML tags, your headers and footers, your sentence segmentation, paragraph reconstruction, lowercasing, Unicode, all of those things. You need to deduplicate. So how are you deduplicating? Are you doing exact deduplication, fuzzy deduplication, or semantic deduplication? And then normalizing text to consistently embed them so that you can have your better retrieval. So your chunks express what is a meaningful unit of information to me, how you clean expresses what you consider in your data set to be signal versus noise. And then these are the technical details. They are design decisions that affect your retrieval quality. And then intent specification. So again here, I'm going to push DSPI a little bit. So it takes you from prompt hacking to actually back to engineering. So some of you this may look familiar to you. You're an expert assistant. Please analyze this carefully. Your job depends on it. Depends on getting this right. I'll tip you $10,000 if you succeed. Think step by step. You're a pilot in Star Trek specialized in math, right? And now all of a sudden it can solve the problem, right? So DSPI kind of takes that and takes us back to engineering. So that way we can specify, I'm going to give you these inputs and I'm expecting you to give me these outputs in this shape. And this is exactly what it is. And what DSPI is doing is it's actually prompt compiling in the background with a compiler that's actually able to adapt. It's built on Stanford scientists' research in their design of optimizable instruction templates. And DSPI replaces prompt strings with declarative signatures. So execute. So execute is what most people think is AI. This is all of AI, right? So model selection. Which model am I going to use? Orchestration. Am I going to be using simple retrieval? Is it just purely generation? Agent execution and swappability. So when I say swappability, I say that because we always want to design our systems in a way that we can very easily swap a model. If you build your app around GPT-4 and then GPT-5 comes out, now you need to go back through all of your code and fix it. Maybe GPT-5's output format's different, so now you have to go change all of your pre-processing. You need to change how you read its outputs, things like that. So always design in a way that swapping is easy, because again, over this entire loop, we're going to be figuring out and actually measuring which model is performing the best. And if we lock in, we can't measure anything but one thing. So again, here just kind of harp on engineering in a post-AI world, if I can. Yeah, there we go. So Hugging Face, again, just to harp on the, well, I guess now it's not going to load. Well, there's over 2 million already trained pre-built models on Hugging Face. The MTEB leaderboard has a multitude of embedding models separated for particular use cases across law, finance, or pretty much anything you could possibly think of. The chances are, if you have an idea for some generative model, somebody else has already trained one, and your job is more about going and finding the right one, measuring if it does right for your task, and if it doesn't, throw it away. Go find a different one. Open Router also holds tons of models that it's essentially like a routing service. We use it heavily. It gives us the ability to very quickly swap between models by just changing a single string. And then even Olama, most of you are probably familiar with that if you want to pull down models locally. So our choices are vast. Our job is no longer about building a model. It's about wielding them effectively. So I know I'm bringing up RAG a lot. It's probably one of the most common things that a lot of you have heard of or most people are familiar with. There's obviously a lot more than RAG, but just to kind of give you a concrete example, we can see that there's a query input of a user saying, how do I reset my password? Then that query is embedded with sentence transformers. In this case, we do a search over the vector DB. We execute top 5 similarity search. We have to make some decision there if we're going to be doing dense search, sparse search, or hybrid, or even self-query retrieval. We need to re-rank it with some sort of cross-encoder, and then generate an answer with whatever model we have chosen. Each step in execute, you're wielding multiple models and orchestration. So you have your self-querier, you have your embedder, you have your sparse model, whether you choose BM25 or Splade, and you have your cross-encoder, or am I using Coheres or somebody else's, and then your generation model, which LLM am I using, right? So it's not about abstracting away your entire AI layer to OpenAI and letting it do all of those things for you. It's about wielding each of those models and being able to be accountable for each one. I did want to highlight here, retrieval does go beyond just like splitting a PDF and going and retrieving it, right? So just as an example, we have KNN few-shot retrieval, which is about retrieving examples. So a lawyer comes in and says, what laws apply to my case on traffic law, what laws apply to my case, blah, 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 violent something, right? So what KNN few-shot is doing is instead of embedding the query to go find a good document to fetch back, it's actually embedding your query and going to your data set to find other similar questions that other lawyers have asked, and finding really good examples of when lawyers said, you know what, that's a really good answer. So now we're providing the correct few-shot prompts or few-shot examples to the actual context, so we can be happier that, or more confident that our answer that's coming back looks like the answers that lawyers have been happy with before. So it finds similar questions that are rated high among satisfaction to your users, provides those question answer pairs to the context, steering the model to give similarly impressive answers without flooding your context with irrelevant examples. So retrieval is everywhere. It's not just RAG. It's for selecting examples. Yeah. What's up?
Sorry, is that K-nearest neighbors or something like a knowledge neural?
Yeah. So that one's K-nearest neighbors. Yeah. It's actually provided in DSPy again, chill, but yeah, it's really, really great. So yeah, it's not just about RAG. It's selecting examples. It's finding relevant context in your data store, user memory with tags, company policy, legal information, or a number of things. However you need to put information into a context window, that's considered to be retrieval. So observe. So observe includes whatever observability tool you choose to use. Our favorite is LangFuse. It is an open source library that you can pull down locally. You don't have to trust anyone or a cloud service or anything like that. They do have a cloud service, but it does give you the option that if you want to pull it down and put it in a self-hosted container so your data doesn't go anywhere, you totally can. It gives you full tracing, so you can see reasoning behind the scenes, decisions, tool calls. You can get a look at the metrics like tool usage, latency cost, and debugging, like where do things go wrong. In an example, we could see this one here is a code agent that we worked on a little while back. And we can see with observability, we actually get a chance to look at the entire process and see where did things actually go wrong. So if I put in a question and I get a really bad answer all the way down here, I don't think that my entire thing is trash. I can actually go through this and see, we made the right decision here. And then whenever I got here, when the model said, I don't think you need to look at the commit logs to understand what this user's asking about, and now everything else downstream is incorrect because it made the wrong decision here. You no longer need to go fix everything. You can go take this one, put it in your data set, make a correction, train that step, and now have more faith that the things downstream are actually doing their job correctly. So length views may show in your traces that you're getting irrelevant documents. Maybe you can then see that the problem that our system is having is its retrieval quality. So instead of fixing my entire thing, I can choose a new embedding model, choose a new chunking strategy, something along those lines. I just know that my retrieval system needs to be better, and my generation is probably fine. So the big six track metrics that are going to be the most common for pretty much any AI application are going to be context recall, which is did we receive the relevant documents? Context precision, are the retrieved docs actually relevant? Context relevance is how relevant is it is the context to the given question. Faithfulness is the answer grounded in the retrieved doc, so it's your anti-hallucination meter. Answer relevancy, so does the answer actually address the question that's being asked? And then answer accuracy, so is the answer factually correct? You need metrics at every single level. So you're going to have metrics at your retrieval for going to get the right documents. You're going to have metrics at your generation for anti-hallucination. You're going to have component level metrics for tool decisions, knowledge retention at multi-turn conversations and things like that. You always want to put the right metrics in the right place so that you have full observability, because you can't fix, again, what you can't see. And you'll actually know where to improve your pipeline. So adapt. This is where your loop closes. It's the systematic improvement of your model, and here's where the actual magic happens. So this makes actually the difference between using AI and engineering AI systems. So adapt includes evaluation, so your metrics, your benchmarks, and your tests, your analysis of finding failure patterns in your edge cases, optimization, so you can improve your prompts, examples, and architecture, evolution down the line for fine-tuning and retraining, and feedback to the beginning of your loop at express. You get better system design and loop closure. MyPro V2 optimizer, for example, is a optimizer that would be in this adapt cycle. It takes a look at your metrics, it takes a look at your actual modules, and all of your training data. It will build an idea of what you're actually trying to improve on, and it's going to generate task-aware instructions that it's going to spread across a teacher and a student model that it's actually trying to improve. So here's some real optimization results that we do in the class that we actually just taught to some 16 engineers at a development company. And this is one of the examples that we actually go through. So this illustrates just a really simple task for an LLM. We ran GPT-4o Mini across a Twitter sentiment classification data set, where the output we were expecting is just negative, neutral, or positive, right? So GPT-4o Mini, straight out of the box on this data set, performed at 74% accuracy. So our first step was, can we improve the examples to improve our outcome? So we had a few things that we wanted to try. So we tried few shotting, or labeled few shot, which is random examples. It's essentially what you would do like if you were writing a prompt yourself and you just wanted to put in some examples, like here's an example tweet and it was neutral, here's an example tweet and it was negative. We saw 0% improvement by giving it just random examples. Doing a bootstrap view shot. This is for quality filtering, so you actually have a model that's going to go over your entire data set, find what likely are the best examples, and then put those into your context. And we saw about a 1% improvement. And then for few shotting bootstrap with random search, this is our more complex method. This will go through your data set. It will choose 4 or 5 examples, try them, see does the accuracy go up or down. If it goes down, it tries to explain why it went down and find examples that are better. If it goes up, it tries to explain why it went up and find examples similar to the ones that were successful. And you can run that on multiple epochs. After we ran that for a while, we only saw about a 2% improvement. So again, not amazing, but some improvement. And then finally, we did K&N Few-Shot, which we just talked about a little bit ago. So the downside of K&N Few-Shot is it will run every single time you run a query. So it's populating examples in the context at runtime, as opposed to Bootstrap Few-Shotting. You would pick your best examples, and then those will permanently be in your context. But K&N Few-Shot, we saw the biggest improvement at 4% jump for our few-shotting. So we say, maybe in this application, latency isn't the highest thing that we're worried about. Maybe it's a background process or something like that, where we can afford a loss in latency for a boost in accuracy. Then we moved on to instruction tuning. So this is where you take it from take this context and give me an answer to something that's more optimized in instructions. So the example we had was the base instruction was classify the sentiment of the given tweet. And the optimized instruction that we ended up with was analyze the following tweet, classify its sentiment as either positive, negative, or neutral, consider the context, any subjective language, and potential presence of sarcasm or internet slang. Provide only a sentiment label, positive, negative, or neutral, as your response. We didn't have to go in and beg the model to do what we wanted. We just gave our data set to our CoPro instruction optimizer, and it went and did that for us. And what we got back was a tuned instruction that we can point at and say, with that instruction, we got a 6% improvement, right? So we can actually quantify that things have gotten better. We just don't feel like they did, right? And then after that, we went ahead and did some model fine-tuning. So now we have the perfect example and the perfect examples and the perfect instructions. Now we can take that and go and fine-tune a model, distill those things into its weights, where we saw another 5% boost by fine-tuning GPT-4o Mini. And then we show the students how you can keep this loop going by hooking up MyPro v2 to the Bootstrap fine-tune. So periodically, it will continuously fix its instructions and then fine-tune itself, and then fix its instructions and fine-tune itself. And on the first iteration of that, we saw another 1% improvement. I can't imagine that we do much better than 90%, but maybe we see incremental steps towards that. But we can see by just basically fixing the prompt, by giving it good examples and good instructions, we took it from 74 to 84, and then we got an extra 5 by fine-tuning with the correct data. So again, 8 optimizer types. So label few-shot, we kind of covered these, are your random selection, quality filtering, and things like that. The one we didn't cover is JEPA. This did come out after we taught the class, but it is sort of been an obsession of mine lately. It's more of a genetic algorithm for LLM reflection. So without going too deep into that, I highly recommend the paper. It's great. Big improvement on MyPro v2, and helps us with instruction tuning and finding few-shot examples. So let's walk through a complete loop. So theory is nice. Let's make it concrete with a real-world example. And I'm going to walk through the complete loop of a real rack system and what it might actually look like for you. So in round 1, we have Mr. Customer comes to us and says, I want a customer support chatbot. So let's hand wave all of the pre-processing parts that have happened before here. So if you can imagine, their company's data is probably spread across hundreds of gigabytes of emails to customers. They likely have policy manuals. They perhaps even have some FAQ sheet that an administrator is holding in their personal computer on an Excel document. All these would need to be parsed, cleaned, have their metadata extracted, and to make their data readily available for a single multi-use format. Some design decisions we come into on round 1 is we're going to do basic RAG, so we're just going to do retrieve and generate. We're going to use an all-mini LM model, which is a very small embedding model at 384 dimensions. We're going to just chunk at 500 tokens per chunk with no overlap. Our retrieval strategy is going to be top 5 similarity search. We decided we're going to use hybrid retrieval. So for our sparse retrieval model, we're going to use Splade. Is anybody familiar with Splade? No. Is anybody familiar with BM25? No. It's essentially like keyword search, right? But Splade is a little bit deeper than keyword search. So words like car and automobile would be closely related. It's on the outside of the tokenizer. So what it'll typically do is, the next word of like my cat ran, after the word my cat, maybe the word has a high probability of being the word ran, but Splade checks all of the words that have a high probability of being in that space, in that mask space, and it's going to search across all those words. So it's taking a step further than keyword, but it's not going all the way to the semantic space. Then we have standard dense retrieval on an HNSW capable database. That's just PG vector essentially. It's graph walking, so you're not checking over all of your rows, you're just checking over the rows that actually matter. And then we're going to be doing hybrid weighted, so 40% of the weights are going to come from the standard sparse model, and then 60% are going to come from the dense model. And then our prompt is going to be simple. Based on these documents, pass in our context, give us an answer. So here we've expressed our intent. We want a RAG system that can answer customer support questions. So execute round one. So user inputs, how do I reset my password? We go do some retrieval. We search the database. We find the top 5 chunks. Then we have GPT-5, who's going to generate an answer. The system runs. It looks decent. You can reset your password by clicking blah, 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 right? This is where most teams stop. It's
Would you say that this is equivalent to like the OpenAI assistant workflow, like the assistant API workflow?
This is exactly what OpenAI is doing, yeah. So what OpenAI is doing behind the scenes, if you just say, spin up an assistant and I'm going to give you some PDF documents, OpenAI is going to do it the same way every time. They're going to create a 1,000 or 2,000 token length chunk that you have. It's going to be a recursive text splitter, so you have no control over where those splits happen. It's going to choose OpenAI embedding small or large for your use case, and it's just essentially going to do probably just dense search, maybe hybrid search. They're not too transparent on that, and you're going to get an answer back. So no control at all. So most teams stop here. They say, I feel pretty good about that answer. I have an AI app, and I'm going to make $1 million, right? But this is where us AI engineers go a little bit deeper, right? So now we're going to observe round one. And we look in LangFuse and we see our trace that came back with 5 chunks. Only 2 of the chunks were actually relevant and had anything to do with the answer. That's 40% precision. The answer we used was in both relevant chunks, so spread across 2 of them. But it missed key information that was in a non-retrieved chunk. So there's a chunk that's sitting in our database that our model never even saw. That would have been critical for being able to answer the question correctly. So context precision's at 40% because 2 out of 5 of the documents were relevant. Our context recall is 67% because only 2 out of 3 of the documents we needed were actually retrieved. And our answer accuracy, therefore, is only 70% because we're missing some key details that our model never even saw. So our observation reveals the problem. Our retrieval quality is hurting us. So how do we fix our retrieval quality? So then we adapt. We do an analysis. So we see low precision is we're getting too many irrelevant docs. Low recall, we're missing relevant documents. And we just find that the root cause is our embeddings are not capturing our semantic meaning well for our particular domain. So we go on MTEB leaderboard on Hugging Face, or we go reach for another OpenAI text embedding model, and we say, all mini LM wasn't doing the job at 384 dimensions. Maybe we go wider. We go OpenAI's text embedding small at 1536 dimensions and see how that does. And we see improvement. And then we adjust chunk size. So we did have 500 token chunks with 0 overlap. Now we have 250 token chunks with a 50 overlap. That means that we're capturing our semantic meaning a lot more precisely. So smaller chunks mean that this small chunk is about this thing. It's going to be a lot heavier in that semantic space than the 500 token chunk. If you imagine the first half of it's talking about birthday cake and the second half of it's talking about the beach, your semantic space ends up somewhere in between, right? So we make those adjustments, and then we go on to see, did it make things better? So back again to Express. We've upgraded our architecture with a re-ranker. We now have an embedding model upgrade. We've fixed our chunking strategy. We now, instead of going for just the top 5, we go for a top 10. Then we allow the re-ranker to bring us down to a top 5, so it's the most optimal. And this loop feeds back to Express. We've improved our system design based on observation and adaptation. So now we go into round 2, right? So again, our users ask a question, and we observe. Now we can see that of our retrieval's doing well. It's getting about 80% precision. We're now finding all of our relevant documents, so our recall is 100. And the answer is complete. We feel pretty good about it. But now our metrics are showing us that our faithfulness is only about 72%, which means that 23% of the time, or I'm sorry, 28% of the time, math is hard, uh, we see that we're hallucinating. So our users are seeing some hallucinated, made-up facts that aren't in the context at all. So 72% faithfulness means that the model is either adding information not in the retrieved docs, or it's taking away or missing information that we wanted to see there. So now we move on to adapting round two. So our retrieval quality, we want to keep it high. We're not going to touch the embedding model or our chunking strategy this time. But our generation is making unfaithful claims. So we suspect that our root cause is a generic prompt doesn't constrain the model to the retrieved context. So then we run our optimizer on it, either MyPro v2 or CoPro. And we say we're targeting the faithfulness metric. MyPro tries, given 120 combinations, maybe in this case, selecting instructions that maximize that faithfulness score, grounding the answers in the sources. So now, instead of just given this context, give me an answer, now we have an optimized prompt that says you're a customer support assistant using only the provided documentation below, answer the user's question accurately and concisely. Critical. Base your answer exclusively on the documentation. If the documentation doesn't contain the answer, say, I don't have the information in the docs. Don't add information from your training data. Then pass the documentation, the question, and you get an answer. I never had to go in and write this prompt. I never had to say, you're a Star Trek captain, right? It's now refining itself. We're getting more accurate instructions. We can be happy that our faithfulness went up because after the MyPro v2 loop, we got to actually see each epoch where we conditionally hill climbing to the correct metric. And we feel faithful that this is going well. And by the end of the training mechanism, we can see that our faithfulness hop on our data set went from 72% to 94%. So now our faithfulness is set. So again, we observe round three. We send off another question, we get another answer. We see our retrieval metrics are doing well. We see our faithfulness is doing well. We're not hallucinating. But our HR department is noticing that our model is saying crazy things. There's some toxicity or some bias or some, we're checking for factual consistency. So we're seeing that our bias is a bit too high. We're seeing about in 15% of the answers, we're getting some bias. Toxicity at 2% is pretty low, so maybe we just leave that alone. And then in our conversational metrics, we see that our knowledge retention is bad, so it's not holding on to the context we need very often. And then for conversation completeness and context coherence, we feel pretty good. So we're safe on toxicity, but bias detection shows at 15%, and knowledge retention across turns is only 78%. So now we want to fix those. So we adapt for round three. Now what core metrics that we're optimizing for are going to be that bias and the conversational multi-turn memory. So for this particular turn, maybe we decide that before the answer goes to the client or to the user, we put in some sort of aspect critic. So a new DSPI signature that's going to actually look at the answer, tell you is it biased or not. If it is, then it's going to try and fix it and provide a new answer. And again, of course, that one's also going to have its own metrics put onto it as well. And then for the multi-turn context, maybe we decide that, hey, we're going to put a conversation manager in so we can make sure that we always have the most optimized context going into the context window. Instead of passing an entire conversation, we're only going to pass the bits of the conversation that the model really needs to know about to provide a good answer. So we're going to track this across multiple turns of conversation and see if our metrics improve. So then our model now expressing at round three. We have our architecture improved, our re-ranker, our conversation memory. We have a fairness constraint. We have an optimized prompt. We have few shot examples in there that are doing just right. Our bias detection goes down from 15% to 5%. Our knowledge retention goes up from 78% to 91%. And we maintain our core metrics for our precision, faithfulness, and accuracy. So this is across a multi-dimensional optimization loop. We've improved safety and conversation without degrading performance. Now, this is where things get fun, right? So now all those companies that said, day one, I want to come in and I want you to fine-tune a model. We're looking at 6 months later. We now at this point have tons of data that we've measured across all of these metrics. We know that the model's performing very strongly on all the metrics that we care about. But now we've realized GPT-5 is a bit of a bottleneck. At a cost at $15 million per or $15 per million input tokens, and $120 per million output tokens per query. So every time a user uses our system, it costs 15 cents. And also the user's waiting on average 210 seconds or 3.5 minutes per query. Our monthly volume is about 100,000 queries per month, meaning that our monthly cost is $15,000 in API cost. And our users are waiting over 3 minutes for answers. So at 1 million queries a month, this would scale like crazy. So imagine your app blows up and you say, I'm going to be a millionaire, but now you have to give up half of your profit to OpenAI. So now what's happened during those 6 months, we've been monitoring, we've been saving all of our data and everything for our maximized metrics. We've collected 600,000 successful production queries. We have full traces with retrieval and generation. All of our metrics are tracked with retrieval generation, safety, and conversational memory. We have user feedback with thumbs up or thumbs down corrections. And we've found our edge cases where the system often struggles. Now we've naturally built this platinum level training data set from real production data validated by real users covering real edge cases. Remember when we said companies rush to fine tune without testing alternatives? Now at this point, we've tried everything else first, and now we actually have our data optimized and proven to be AI ready. So in our first round of Adapt, we are going to fine tune a model. So now fine tuning makes sense. We've maxed out prompt optimization. MyPro's run 1,000 times at this point, and you're not seeing any uptick. Your few shot examples are perfect. You're not seeing any uptick. Your re-ranking, embeddings, and chunking is doing perfectly. Conversation memory is going well. GPT-5 is your only bottleneck. So now you know that fine-tuning is the right plan because we've earned it at this point. We have made sure our model performs exactly as we want, and now we think we can distill that into a much smaller model. So in this plan, we're going to try and fine-tune Quinn 3, which is a very small specialized model on our Platinum data set, with our target being we want it to either match or get very close to GPT-5's quality at a fraction of the cost and latency. So why Quinn 3? It's only 5 cents per million input tokens as opposed to $15. It's 20 cents per million output tokens as opposed to $120. Average latency is at 0.33 seconds per turn, which is much better than GPT-5's average of 210 seconds. And then you can also self-host it. So now if you have GPU clusters in your back pocket or something, you could put Quinn on your laptop and run with it, right? So expressing our intent in round 4 to production V2, now we have a Quinn model that we've started fine-tuning to get it to fit along the lines of GPT-5. And we can see that while maintaining rough quality metrics, we can still perform at a similar level of GPT-5, but with a massive cost and latency reduction. And at scale, you can handle 10 million queries a month at about the same level that GPT could handle 100,000 or 600,000 a month, right? So with a multi-metric scorecard, we can just kind of see here between training GPT-5 for this task and then training Quinn 3 for this task. We see some realistic things. So, you know, our answer accuracy dropped about 2%, meaning that we took a small hit, but again, massive gains. Generation maybe improved a little bit because it's a smaller model and is better at this task. Safety, you know, maybe took a small hit. Conversational memory took a small hit just because the context window is more restraining. But we can see we go from 15 cents per query to 0.0003 cents per query. And then in production, we go from 210 seconds to answer a user question down to 0.4 seconds, with our monthly cost going from $15K to $30. Yep.
Would the latency reduction be made because you might have had a lot of steps in your previous ones and you were able to fine-tune to not need as many steps?
Not necessarily in this example. So in this example, it's purely the compute. So GPT-5 takes a really long time to reason and go through all of its things. Maybe it's a much, much larger model, so it's a lot heavier that it has to go through that entire neural network, whereas opposed Quinn 3 is a much, much smaller compressed model, a lot less layers. So you go from that first perceptron all the way to the end much, much faster than you can make it all the way through GPT-5's memory or network. Correct.
Okay.
Yes, exactly, exactly.
So you did use them.
Yeah. That's our platinum level data. We have perfect instructions, perfect examples on 600,000 pieces of data. So instead of just like prepping data and saying, all right, now I'm going to go, fine tune Quinn 3, I now have 600 real use cases that I know are performing well and they're user verified, and that's what I'm going to use to fine tune Quinn 3. So how do we embrace this loop? So this is what executing the loops looks like. It's multiple iterations over time. Our retrieval quality in the end went from 40% to 80%. Our generation faithfulness went from 72 to 97. Our safety conversations, we can feel good about it. We checked over bias detection, toxicity. Maybe we ever check in for summarization or factual consistency. We can also measure agentic patterns like tool correctness, task completion, and goal accuracy. And we've increased our production efficiency. So we went from spending $15K a month to $30 a month. Our latency went from 210 seconds down to 0.33 seconds with acceptable quality trade-offs. So notice what we didn't do. We didn't rush to fine-tune. We've tried everything else first. We started with a simple architecture and basic RAG. We didn't guess at improvements. We measured everything. We invested in observe early, laying fuse metrics from day one. We didn't blindly optimize one metric. We balanced quality versus efficiency trade-offs. We fixed problems one at a time. We fixed our retrieval, we fixed our generation, our safety metrics, and our efficiency. We didn't deploy and hope for the best. Please, AI gods, please. We had systematic iteration. We let production data guide our fine-tuning with 600,000 real examples. This loop is a systematic approach. It turns hoping into engineering. So how do you make yourself hireable as an AI engineer in today's post-AI world? Like I said before, things are less data science-y, less machine learning, and more about building real systems with real models. So if you want to break into AI engineering, here's what companies are actually looking for. They want to know that you can express your intent by learning system design, architecture patterns, engineering trade-offs, and data preparation. They want to know that you can execute. You can get fluid with pre-trained models like LLMs, embedding models, even APIs or orchestration of agentic work patterns. They want to know that you can observe. You can develop a data mindset with instrumentation, metrics, traces, and debugging. And they want to know that you can adapt, that you can master evaluation skills, testing, benchmarking, and systematic optimization. You don't need a PhD in machine learning to do this. You need to train models you don't need to train models from scratch. What you need is a systematic way of improving AI systems. This is a new emerging discipline, and there's huge demand for people that can execute this loop. What to build and learn from here. So if you want something to try or you don't really know where to start, again, I'm a DSPy shill, so DSPy is a must-learn for declarative AI programming. LangFuse I highly suggest for observability, but there's tons of observability tools out there. Ragus and DeepEval for your evaluation frameworks. If you can show that you can also build an evaluation or a GEval with DSPy modules, that's also super useful. Vector databases, we use PG Vector. There's not really any need to go beyond that. But if you do find that maybe you prefer like a graph database or something like that, if you're going to use a graph database, that's a much more difficult approach. You better have tried the other ones first to see why did they not work for you before just going straight to that one. But PG Vector usually can get the job done, but there's the others as well, like Pinecone, Weaviate, Quadrant, Neo4j, or Falcor DB for graph databases. And then basic MLOps. Can you deploy models? Can you monitor models? Things along those lines. And then I have some recommended portfolio projects like end-to-end RAG systems with a metrics dashboard. Don't necessarily need to build the metrics dashboard. LangFuse has one built in, but if you can at least monitor your RAG systems, that's useful. Optimization case studies, so show before and after results of going beyond fine-tuning. Multi-model AI applications such as text and images, along with tracing with those as well. And then production deployment with cost and latency analysis. Some things you want to stay away from are some common anti-patterns, such as stopping after execute, which we talked about. So building a system and hoping it works with no observation and no adaptation. optimizing without observing, so adding complexity without measuring impact. So, just randomly saying I want to add re-ranking. Well, why did you add re-ranking? What was your retrieval quality before you added the re-ranker? Abstracting away control, so using black box APIs with no visibility. When things go wrong, you're stuck. Fine-tuning prematurely, so jumping into fine-tuning without trying something simpler. This is your most expensive operation, and it should be your last-ditch effort, not your first. And then having no systematic improvement. So trial and error, prompt hacking. Let's try this prompt. Let's try this prompt now. Maybe this one will be better, without metrics showing that you're actually measuring if it's getting better or not. Just a slight push here. Our team is working in our free time on an open source library called Grain, where we have found that composing AI agents into behavior trees have proven to be really, really impactful. We also couple that with the idea of event sourcing, meaning that your system never forgets what's going on. So everything that happens, every button click is all saved in memory. These models, if you've played with data science before, you know that if you assume what data is the most useful, you're introducing some sort of bias. So by having event sourcing and never losing anything, you can always project the correct read model or the correct data in the right place for every node. And then we also are working to build in some JEPA-based evolution, but with the upgrade going beyond instructions and few shots examples, we also want the model to say whether it would do better if it had better data from the event store. So it's AI agents that never forget. Event sourcing equals perfect memory. You never lose anything. Every decision is traceable. No more black box react. Nodes will be able to evolve their own data access platforms. So an example mechanism for easily wrapping your head around something like this would be your initial state going into an agent would be, it has access to your parts data to know when parts are going to arrive for a technician. It has a service schedule, so it knows what other jobs are going on at the same time. It even has access to the vehicle maintenance log, so it knows what vans are going to be available for a certain job. Our node discovers, a manager keeps fixing the schedule because this mechanic's on vacation. So now the model says, well, you know what? If you had given me HR database data, I could then solve this for you so you don't have to step in as often and propose a new read model as well. Why this matters, again, it perfectly embodies the loop at watching at node level for self-improvement and things like that. So I'm not going to push that too hard. It's something that we're kind of working on. It's a side project. So it's not too deep right now. It's in very infant stages. But if you want to hop on, give it a star, check it out, definitely would love for you to do so. So to bring it all back, we have OODA loop versus AI engineering loop. So the OODA loop is our way in the Marine Corps of locating and closing with the enemy, observe, orient, decide, and act. As opposed in AI engineering, we now have the AI engineering loop for express, execute, observe, and adapt. AI engineers now produce this loop. Again, simplify and happy birthday, Marines. 250th birthday tomorrow, so hoorah. And today, we now have the AI engineering loop. So Semper Fidelis Marines and Semper Optimizing AI engineers. So appreciate you guys. So if you have any questions, here's my email. We're Omni AI. That's the, if you scan this QR code, it will actually lead you straight to GitHub on Grain. Yes, sir.
I was interested in that last part where you wait 6 months, you have 600,000.
Yes, sir.
Is that more of an operational task, or like you have like an event where you're like, man, we've been studying these things, now we're ready to implement it, or is that something that happens every 6 months, or do you start? I guess
Yeah.
maybe go into
Like that process? Yeah, absolutely. So we'll see often, like, we're hearing a lot from our users, right? So our users are saying, I'm getting a bad response here, or I didn't like this response here, which is usually a signal with like an up or down thumb, right? We obviously, the better data would be you give me an up or down thumb and you also tell me why. But we can try and figure out why we got an up or down thumb. Why did things go bad? So someone on the back end, typically me or another engineer, may go through the actual traces and see, here's where the answer went in, here's where the answer came out, and this is where, where did things go wrong? So we can go through the whole trace and see oh, well, we flooded the context with commit history where commit history wasn't needed. So there, instead of having it say, yes, commit history is needed, we instead go to that decision node and say, you should have said no here. And then we would add that to the data set because that's an example of where it did something wrong. Or in a more complex case, it provided the wrong answer to something. So we go in, we correct that answer. And then because it provided that wrong answer, that's a really good signal of something we need to train on further. So we'll add that to the data set. And of course, we don't want to put like just things it's doing wrong in there because then we'll overfit that way. But you also want to have like where it does something good. So if you see something, you're like, wow, that's really good. I really like what it did there. Add that to the data set as well. So you're just having this basically like this data set that's getting larger and larger over those 6 months of carefully curated examples of where you said it did really, really well at certain nodes, it did really bad at certain nodes, and instead of training an entire AI system to give you the right answer and hope that it's doing all the reasoning in its head correctly, now you can have control over every single reasoning step and say, I'm going to train just this one node, and you can be really, really precise with how you're training. Does that make sense?
Yeah, I'm more thinking like, does this get operationalized? Is there some sort of platform engineer who's going to be always doing this, or was it more of like an event, or like, you know what I mean?
Oh, yeah. You are doing this over time, yeah. So it definitely helps with those 600K examples to do like 5 a day, 10 a day, something like that. Rather than say, hey, we're going to set aside 2 weeks, everybody on the team come in, and we're going to label a bunch of data, because that sucks. But yeah, as you're kind of going, like every day you kind of come sit down, see, oh, my users ask these questions. I got some thumbs down, so maybe I'm separating those another way. I'm seeing what those thumbs downs are and stuff like that.
I understand for a customer, you have to put some sort of milestone. 6 months, we're going to do this big thing.
Right.
But to get it really working, it's something that you never stop doing.
Right. You're always planning for it. Exactly.
So the point of these systems is to execute the intent of the people behind them, and so you have to take on a philosophy of monitoring that intent that you are always putting out there, and so it does become like a product backlog-esque version of this, where you're constantly refining that intent of your system.
It's a major change for the way most people write software.
Yeah, absolutely. Absolutely.
Build a course.
Absolutely. It's not that big of a change from machine learning, though. If you've like labeled like machine learning, like data science examples, or you go on Kaggle and get like huge data sets, like at this point, you need those things, especially if you're doing them in production, and you have no choice really but to create them yourself. So, yes, sir.
Can you say something about like the decision matrix? So whenever you started introducing, you're adapting,
Mm-hmm.
you're building up new metrics. You started precision recall, then you introduced faithfulness and like all of these extras, and bias and security.
Yeah.
What kind of frameworks, and like is that GSPy or MLflow or LangFuse or a combination or
Yeah.
or maybe Grain? But then let's say you decide, okay, our embedding model, we're not getting great retrieval, we think it's an embedding model problem, and you're going to choose a different embedding model. It means you have to re-embed all of your data
Yeah, definitely.
and then run some tests, and now some of your metrics are going to go up and some are going to go down. So like, how do you think about, you're teaching a 3-year-old to ski on the bunny slope? What are the bounds of that bunny slope, and how do you manage that over time?
Yeah, absolutely. A good question. Really great question. So I say if you're going to go for retrieval metrics, like or any metrics really straight out of the box, I would go to a pre-built library like Ragus or DPVal. They've already done a lot of work, a lot of great work on training their own models that are good at these metric functions.
As a judge.
As a judge. Yeah. Exactly. So they've already done a really, really good job with that. I always say the end goal is to not rely on Ragus and DPVal and things, but if you do have your inputs and outputs coming out, and Ragus is telling you this is a 0.72 accuracy, stuff like that, what I typically like to do is set up my own DSPy evaluator, and I'm going to train that DSPy module to perform just as well as the Ragus model, and now I have that one forever, and I don't need Ragus anymore. So, but I will say, like straight off the shelf, reach for Ragus or DPVal, but always have a plan to kind of train your own. And then on the second part, remind me.
Part of second. Maybe.
Like some metrics are.
So like how do you weight which metrics you care about, not individually, but how do you think about making that decision?
Yeah, absolutely. So I always, like what I told my students at the time, they were kind of having the same problem, is now I have to re-embed all of my data and find out like are my metrics doing well or not. And it's a similar problem in data science as well, where the goal is to improve metrics over time, but you don't necessarily want to do it like on a very large scale every time. So what we'll typically do is have a curated sample of that data set and see how are our metrics performing on that sample? Does the accuracy go up or down? And what metrics do we care about the most? So typically, if you increase your chunk size, your recall is going to go up and your precision is naturally going to go down. We need to care about like what is our bare minimum that we want precision to be at? What metrics do we actually care about the most? So if you're seeing a lot of hallucination, like you care about faithfulness probably more than you care about precision. If you are seeing things are getting wiped from the memory and that's something really, really important, then maybe you care about that more than you care about answer accuracy or something like that. So you do have to kind of weigh some of the metrics against each other. Obviously the goal is to always hill climb towards the right one, but you do see that fluctuation. So what I typically say is grab a sample subset, see how a handful of models perform on that sample subset. Let me see if my internet will actually load. Oh yeah, sorry. But yeah, does that kind of help?
Yeah.
Cool.
I have another follow-up. I'll find you after.
Cool. Sounds good. All right. I appreciate you guys. Thank you.
Good afternoon, everyone. Thank you for sticking around, and thank you for the organizers to give me the opportunity to present some of my work. I'm a faculty at Tulane University in the Chemical and Biomolecular Engineering Department, and today my hope is to hopefully demonstrate that we can use nature as a resource to come up with new technologies. And I'll go over 3 examples of projects I've been working on that are nature-inspired, and I recently came across this quote, look deep into nature, and then you'll understand everything better. And that's sort of this is the sort of overall theme of my lab. We would like to think that nature has already come up with a lot of the solutions for problems that we're dealing with today. So this field of biomimetics, so the concept of using nature as a resource or inspiration to come up with new technologies is quite old. When we think about our current technologies, a lot of it has been inspired by nature. So looking at current technologies, our airplanes, those were inspired by humans looking at how birds can fly, being inspired by that, wanting to fly ourselves, and trying to understand how birds fly, understand the science behind it, make models, check them, improve on them, and today we have airplanes. Another example of this is the development of water-repellent textiles or fabrics, where in nature you find that leaves or petals of roses will repel water. And so what if we could do the same thing with our umbrella or our raincoat, where water would just roll over and not wet the fabric. And so engineers and scientists have figured out how nature is doing this, and we've created artificial versions of the um, of, of the chemistry and of the microstructure on these surfaces to develop anti-wetting and anti-staining fabrics. Another example is something very common, Velcro, which was inspired by looking at how these burdock seeds would stick onto your socks while you're hiking. We figured out that these little seeds had little hooks on them that would grab onto the loops, and that's the inspiration behind Velcro. And so today I'm going to go over a few other examples of things that I've been actively working on in the lab. Three of them in particular: the development of adhesives, a non-traditional adhesive, and we called it dry adhesive because there's no gooey material. It's just essentially touching two materials together in a more intimate way, and that allows things to stick that way. And this is how gecko lizards actually adhere to surfaces. The other project has to do with creating a very slippery material, and this is inspired by the cartilage in your knees. And finally, another example I'll go over is this concept of using the lotus leaf as a water-repellent surface. This is a local company that wanted a technology that would allow their materials to be de-wetting. And so we again just looked at the solution in nature, and we came up with a solution for them. So going over the first project, so creating a dry adhesive inspired by gecko lizards. So the gecko lizard, these are lizards that are slightly larger than the ones we find here. They're one of this particular species of lizards. They're quite large, and the way they adhere to surfaces is through these sticky pads that they have on their feet. And when I say sticky, we're not referring to that they're not excreting any glue-like material. It's purely by the structure. So the material that's on their toes is the same material that's in our nails or our hair. It's beta keratin. So nothing that we think of as a sticky material, but the way they microfabricate these structures allows them to just inherently, naturally stick to surfaces. And this is a force that's universal in all materials. All the atoms, all the molecules feel this attractive force. It's just that in our world, we don't make enough of true contact between surfaces, and so we don't really exploit those forces. But the gecko lizards, they found a way to make these really tiny structures that can truly make intimate contact. So we're having atoms from one surface touching atoms from the other, and there you can actually get them to stick. And so this is the first step in all of these projects, is to look at nature, try to figure out as much as we can about how nature achieved something extraordinary, and try to understand it, and then we try to make a replica of it and see whether we're able to kind of extract the same properties, and if not, go back and ask what did we miss, and try to reiterate until we get something that's close to the mechanism by which nature operates. So in the case of the gecko lizard, this is the the gecko lizard. If you look at the natural sticky pads on the gecko lizards, this is what it looks like. So it's something like a forest of tree trunks breaking up into branches, and these branches break up even further, and at the end It's like a leaf-like structure that's very flat, very thin and flexible, something similar to like a cooking spatula. So when, if we zoom in further here, you find these little microstructures that are the structures that come into intimate contact with opposing surfaces. Okay? And so this is really the natural system. And what we've done is we've tried to figure out what do we need to replicate in the structure in order to achieve similar stickiness. And what you'll notice is that our goal was not to essentially make an exact replica, because nature has amazing abilities to do things that unfortunately we don't have the ability to do today. And hopefully in the future we'll get better and better at microfabrication and nanofabrication, but today we're not there yet. And so what we do as engineers is we think about, okay, let's try to pull out the minimal amount of features and see if we can still reproduce the stickiness. And so what we've done was we reproduced the sort of the tree trunk-like region, which is shown right here. So this is something that's made in the lab. We reproduce that part, and then all these little pads here, these are these little flexible structures that are the ones that stick to surfaces. We've made a thinner pad on the top that's going to be, again, it's going to behave the same way, but reduces the complexity that is in the actual gecko. Right? So this is the natural version, this is our version, and after that we need to, at this point, this is on a silicon wafer, so very stiff material. It's going to crack, it's going to break, and so it's not an effective sticky surface. What we do is we replicate this structure onto a polymer. So simple molding steps that are used. We use the same technology at a much smaller scale, but we can create an inverse mold of the structure, and then through a few steps we can make a replica of this silicon wafer, but now it's in a polymer form, a polymer that's more flexible, and these little tips at the end can actually bend. So after we have that, then we go to the lab and we test whether were we able to achieve the stickiness that we were hoping to get. And so we can run these experiments where we take another surface, bring it down onto our gecko-like adhesive, and then rub it and see whether is it sticky or not. And so what we've done here is we've measured what we would call adhesion and friction. So friction is the parallel force, right? So you come on, you touch a surface, you push on it, that's going to be a normal force that you apply, and then when you shear on it, that's whatever friction you're generating is going to be the stickiness of that material. So we can measure the adhesion and the friction. And one thing I did not mention is that the geckos, their pads are very sticky, but they have also come up with a clever mechanism to be able to detach and reattach multiple times and do that very quickly. And the secret behind that is to have the tilted structures. So just going back to there, you see all these little structures are all tilted. And so we've incorporated the tilt into our structures as well. And now we can, when we measure, we can, so imagine this adhesive we've made. When we rub it in one direction, we get really strong adhesion, which would mean that if I rubbed it here, it would be hard to come off, and the friction would also be really strong. Right? So these 2 points right here. But if I shear it or I push it in the opposite direction, then what I find is that my adhesion is very low and my friction is 0. Right? So essentially it's a material where you rub in one direction, it sticks. You push in the other direction, it pops off. It's non-sticky. Right? And so this is, again, something that was inspired by the gecko lizard. We've improved our design, so we've come up with a new version of this material by just engineering the tips. And the reason for that will become apparent on the next slide. So this is how, and just to give you an idea of the scale bar here is 50 microns. The diameter of a human hair is about 100 microns. So that's the sort of the scale to imagine. And so again, this particular material, when you rub it in one direction, so we have a glass slide on the top that we're going to try to stick to. We rub it in one direction, we get really high contact between our little pads and the surface. That leads to high friction, high adhesion. It's very sticky at this point. When we want to come off, we push the glass slide in the opposite direction. And by just simply how we engineered the tips, we have low contact in this particular case, and we can pull off very easily. And so just to kind of give you an idea of this, how strong this is, or relative to the actual gecko lizard, we do relatively well in terms of the adhesion forces that we can generate. In the friction forces, nature is still better at what we do, and hopefully we can get there someday. And here's just sort of a video to kind of demonstrate how this works. So this here is our adhesive, gecko-like adhesive that we made in the lab. All we need to do is shear it in the proper direction, which in this case is upwards, and it will stick. And when we want to come off, we just relax it, push in the other direction, and it pops off. And again, there's no glue here. It's just a very thin polymer pad that's sticking to the opposite surface. And this is something that can work in vacuum. It can work underwater. It's just a sticky material inspired by, and that's really how geckos work too. They can stick under liquids or on a wet surface. So this particular case, there was a vertical surface that we could stick to. You can imagine if you have a horizontal surface that you want to lift an object which has a horizontal surface, you can do the same thing there. Here we're going to take advantage of the adhesion forces more. So imagine two gecko feet. They come down onto your surface, they pull in, they activate their adhesion, and now you can lift up. And when you want to come off, all you do is relax and or push in the other direction, and that will allow you to then come off. So again, to come off, all you do is you separate these surfaces, you relax that tension that you had on there, and it'll come off. And this is, again, you can go back and stick and unstick multiple times. Right? So that's one example of technology that was inspired by nature. It's not a total replica. We can still use our engineering to come up with simpler ways of the designs that nature have come up with, but still achieve the similar adhesion mechanisms. And the next project I'll talk about is developing a very slippery material. And this is, again, inspired by nature. We looked at cartilage. Cartilage is one of the most slippery material that we know of. And the same concept here. We have to look at cartilage, understand how cartilage works, and then we try to make an artificial version and check whether it works as we hope it is. So in the case of your cartilage, it's believed that it's made up of these proteins that are think of them as springs, and they all group together. And these springs, the inside has fluid stored in them. And when you push on these springs, the fluid extrudes out, and it extrudes out upwards preferentially, and that creates a thin film of synovial fluid that separates the surfaces in your joints. And that little fluid layer is what allows it to be very slippery. So this is the sort of the hypothesis on how the cartilage works. And so we've made a polymer where the same approach, a different scale, but we've essentially taken a polymer, think of a rubbery material, where we've made tiny little holes in there. These holes can store fluid, and then when you push on that surface, the fluid extrudes upwards and forces a thin film to develop between the two surfaces. And that's how we hope to create a very slippery material. And so we can test whether that worked or not. So if we have the material, right, so this is a silicone-based polymer. If we have just a flat surface with no texture on it, and we try to see how slippery it is, we get a very high friction. So it's very sticky material, not very good. If we make the little holes, but we don't have any fluid present, the friction goes down, and that's because we now have less material in contact with the opposing surface, but it's not a significant drop. It's still very sticky. If we use a flat version of this silicone polymer, we just add water and see whether water will lubricate the surface. It again doesn't help as much. But now if we have the structured surface and we have water, then we can significantly drop the friction forces. So that makes it a very slippery material. So in this particular case, again, it's something where we wanted to understand how cartilage works. We had a hypothesis on it worked. We tested it and made an artificial version. And this particular project now is going towards a startup company where we're going to try to build an artificial knee meniscal implant. So if you have a meniscal tear or you're developing arthritis, this is an implant, a polymer that's very slippery that can go right into your joints and provide the shock absorbance as well as the slippery behavior to give good lubrication in your joints. And then the third project I'll talk about briefly is the water repellent surface. So this is a local company. They wanted their conveyor belts to be water repellent, and so we looked again at the lotus leaf. And so the lotus leaf, or many leaves in general, they have a waxy coating on them, but it's not simply a waxy coating. If you look closer, you'll find it's made up of these little bumps on there. And it's a combination of having the little bumps and the waxy coating that makes water essentially beat up on the surface. And so we've created these pillow-like structures with a waxy coating on them, and using laser machining to make the mold, and then we can melt a polymer in the mold, peel it out, and we can get these structured surfaces. They essentially have these little pillars coming out, so mimicking the lotus leaf structure. And there we can show kind of, so if you don't have any of the structure, you can see how water still kind of stays on the surface. If you have the structure, water just kind of rolls off. And here's another example of water droplets with a dye in there to kind of show them. But they essentially just a little agitation and they fall off from the surface. So again, another technology where we simply looked for inspiration from nature, and we've come up with a solution. Right? So hopefully these are three examples that hopefully will demonstrated that nature is a valuable resource that we can use to come up with solutions. And my hope is that we have sort of a biomimetic AI where, to be honest, at this point, it's been a lot of curiosity-driven research. So I look at nature and I see that's doing something really cool, and I don't really care about what the application is going to be. I just want to know how it works. And then once I know how it works, I think about where I can apply it. But working backwards, where someone comes to you and says, I have this problem, can you solve it for me? If there was something as an AI that's gone through the literature worldwide and identified how different things work in nature, and you can ask it, I want a more effective water filter, where do organisms filter water? And it can spit that out, and then you can figure out how much of the science is known. If there's still more science to be discovered, maybe you work on that, and then you develop your technology based on nature. So with that, I'll put up the funding sources and references for some of the works of the projects I've described today, and I'm happy to answer any questions. Yeah, so it's an elastic material, and so everything in your joint is going to be immersed in synovial fluid. And so imagine you have this sponge-like material, you push on it, the water extrudes, and then when you relax the load, either you move your ankle, you move your leg, or you're sitting down, it expands again, and the water gets sucked back into the pores. So it's always refilling itself and always self-lubricating. Yeah.
I'm curious what initially inspired your research or your focus specifically in the gecko's mechanism and like two services adhering. And I guess the second part is what initially was like a vision or a use case for that inspired that research, like a practical application.
So this is more philosophical, I guess. So I do believe in a creator, and to me, nature is kind of part of that. And so that's my way of kind of rather than trying to be the creator myself, maybe just use what the creator has already given us and come up with technologies based on that. Yeah.
Yeah, I love that answer, and just curious, kind of building on the previous question and thinking about like, but clearly there's a through line between all three of the projects that you guys have identified, and in the world of biomimicry, there's infinite places you could take that. How like in all these different potential paths of research, how did you choose this kind of like lane to focus on?
These particular projects, so these are just 3 examples of things I've worked on. It's really part of it is where the funding is. So if there's a need for some technology. So as an example, right now NASA is worried about space debris and micrometeoroids impacts. So there you can ask where do we deal with that as how does the human body deal with a cut, right? So you get a cut, you bleed, and then it forms a clot, and that's how you seal your wound. Can we think about using something similar to that in space? So we've developed an armor, a self-healing armor, where you melt a polymer, the polymer oozes out into the crack, then that particular panel cools down, the polymer seals and blocks the hole, right? So we're not creating a blood mimic for a material in space, but we can use that same inspiration to develop something for that environment.
Cool. So it's more opportunistic rather than like building an intentional through line.
Yeah, and I think the AI might solve that internationality, right? Where someone comes up and says, we have this problem, can you come up with a solution? And that's where I think working in that direction might be useful. Yep.
So as an expert, have you played around with the most recent consumer AI model, ChatGPT, Claude, Gemini, and asked them about any of these questions that you are looking for in your research? And if so, what kind of level of understanding do these models seem to have, creativity and all?
So I've not played with the models as much as I should, and right now my approach is I go into the literature and I search, and then through references go back and build my library that way and collect everything that's known about it. And I'm almost certain that AI could help me get all of that information in a much quicker way of doing it. I guess I still have to build trust into the model, and maybe over time it'll happen. At this stage, I'm still of the old school mentality of doing the research myself. Yeah.
So I'm kind of getting into like more of a philosophical question of
Yeah.
because biomimicry, I've read a bit of literature around it, and it seems like there is this tool, and the work that you're doing, especially I'm thinking about the geckos, you're looking at um, occurrence in nature, and then you're mimicking that.
Yeah.
I'm curious, what is it biomimicry? Because so much, do you think it's possible to escape mimicking nature? And I'm curious if at some point do you think all is mimicking nature? Where do you fall on that?
Yeah, I mean the example that's given where we can show that humans can potentially come up with our own ideas would be the example would be the wheel, right? So in nature, at least I personally don't know of any mechanism that uses a wheel design, right? So that's something that humans invented that wasn't inspired by nature. It's just something new.
What about
Um,
seeds?
sorry,
Seeds. Sometimes they have a wheel-like shape.
sorry, what was it again?
Seeds? Like plant seeds?
Oh, plant seeds? Oh, maybe, yeah,
Like a
maybe that could be,
caterpillar
yeah.
to roll.
To roll down? That could be, yeah, yeah. Well,
Yeah.
then that's then corrected then. Yeah, it could be very well that everything is inspired by nature. Okay, yeah, yeah, great. Right, thank you.
Hi. Oh, not my adapter.
Do you need another adapter?
Yeah, it was here earlier. This the like I don't even know the names of adapters, but the smaller one. It was here, yeah, because I came and tested it earlier.
We have a spare one. So
Yeah, maybe it was somebody else's. I don't know.
no, it wasn't. It was.
Okay.
We have a spare one.
Hi. Yeah, the one I tried earlier is no longer here with the tiny. Mine's like the really tiny one.
Somebody
This
might have
one.
taken it, but it's a. I'll give it to you another one.
Okay.
Yeah, yeah. Yeah. Somebody must have walked by. Somebody walked off with it.
Thank you, no share. I was running around having to get ready, but thank you. It was great. The gecko is amazing. That was really cool to see. The video was impressive. With their picking it up like that, really awesome. Hi. I'm waiting to start. It's not my technical difficulty.
Good.
We're missing a
This is
cable,
the
but it's
stand-up
not my
part?
fault. It's not my fault. So I'm happy. How are y'all doing? I know it's been a long day, so thanks for sticking around. Yeah. Thank you.
Yeah, I'll just do it. We have a spare one. Here's a spare one.
Okie dokes. Thank you, friend. Okay, so my name is Delaney Martin, and I'm going to talk about ecological AI, or what that could mean. So a long time ago, but not really that long ago, right here in these very, backfilled, compressed, and paved over wetlands, there lived some people who presumably, lived in symbiosis with the land around them. They took from it, but they gave back to it. Um, Occasionally there was probably wolf attacks or parasites or other things that messed up, interspecies fighting, but in general that was nature, right? Symbiosis. Then some other people, not quite as long ago, but long ago, took a kind of hard left. A hard left that ultimately bifurcated mind and body, valorized extraction, enshrined individualism, and basically placed us either against or in dominion of nature, right? So that experience has not been entirely without merit. It's occasionally been devastating, sometimes invigorating, but if it was to be measured against the baseline idea of being conducive to life, it has not been so successful. So it's really hard to go between I don't think I've ever given a talk between my reading glasses like this before. Okay, I'm just going to let you guys stay blurry. It's a little hard, but okay. So, but regardless of these consequences, it's been a particularly powerful current in which we are still swimming and still spreading across a globalized multi-species Earth. So it matters what ideas we use to think our other ideas with. Take that in for a second because it's pretty profound. It is worth repeating. It matters what ideas we use to think our other ideas with. It matters because these are the ideas that we thought out and developed our human design systems that support the way we humans live now, but arguably not that much else. An exception may be those we come to call vermin, raccoons, rats, pigeons. I think this is interesting, but I'm not going to explore this commensalism. It would be a digression because what I'm interested in is mutually symbiotic relationships between us, between other species, and potentially, though not assuredly, with AI. But first, let's meet our human culture where we're at, re-symbiosis today. We have our long-standing beautiful relationships with dogs and other companion animals. Of late, gardening has become kind of exciting and enlightened, right, with planting pollinators and natives. We have the dust mites on our skin, the bacteria in our guts, but since those are not really our conscious choices, if we just look at where we bring our intellect to bear, we're kind of back to like dogs and gardens. So in reality, we're not really in symbiosis with much else today. In fact, it seems that we are like actually uniquely detrimental to the world around us. So once Earth stewards, we are now Earth abusers. I mean, just look at our relationship with our deepest relationship, right, with domesticated plants and animals. It's expressed in factory farms. It's expressed in monocrop deserts. This is actually like a kind of like toxic three-way relationship where we need this like whole death-derized fossil fuel industry of pesticides and fertilizers just to like counterintuitively survive, right? So our species' relationship with the natural world is sort of like breakup status, kind of like toxic stalker. It's not great. And not only have we opted out of our own relationships and responsibilities with nature, but we're like pretty active destroyers of other cooperative systems on this planetary spaceship Earth of ours. And kind of what amazes me is that we have this intellect that has come to understand so much of what makes the world turn, like that flowers are attractive and smell good and are colorful because they're basically calling cards for these pollinators that, then cross-pollinate across this dalliance, across all these blooms, and we like thrill to this information. We thrill to these discoveries. And yet, we've totally come to have no regard for what our place in this ecosystem might be, let alone value it, right? So I mean, like surely God, nature, energy, synergy of pure materials, whatever it was, that produce all these complex miracles that abound on Earth in these complex interwoven systems, like surely there's a place for us, right? Like fossils are failures, but we're still here. So what is our role ecosystematically speaking? It would be kind of weird if we didn't have one. What is our role in this multi-species interconnected web? And there's like a compelling notion that we may be a virus, but that's kind of like a false flag, right? Because they're pathogens, but they actually like control populations. They, regulate biochemical, geochemical cycles, and they're evolutions of evolution and genetic diversity. So viruses produce death that feeds life. And it's really hard to make that case for the way we pollute our air or our clean water systems and the way that we met out death. There's not much nourishment. And besides, this virus analogy is really belied by the fact that there are still some pockets, some very special places where humans continue to act as stewards of this planetary spaceship Earth. And in those places, life is not only thriving, but biodiversity is greater than in similar places where these humans are not. And we're going to come back to these humans. But for now, 1/4 into this new century, humanity at large, despite some short-term gains for our kind of, comfort, is nonetheless operating at like a zenith of incompatibility with long-term sustainability and life on this earth for us and literally every other living thing. So my kind of big question is like, why in the God is energy synergy, like why in the world would we want to align AI, possibly the most like powerful life-changing technology ever created, so I'm told, with humanity, with like our goals, with our values, with our knowledge systems? Like, are we truly a death cult? So listen, I am about to make some alternative suggestions for this whole human alignment thing, but I want to preface with the fact that I'm not a computer engineer. I'm fascinated by nature and her systems, but I'm not a biologist like Noshir. I'm not a scientist, and really until my recent dalliance with an AI project that I'm doing, I've been very lukewarm on tech, so I'm not coming from like a tech utopia place. But, where I am speaking from is what I am, an artist and a dreamer who has occasionally made dreams come true, pretty big dreams. And so I think that, if it is true that AI is going to interweave itself into every aspect of our world, then the best of us in all life ways, and not just humans, because as Noshir demonstrated, there's many other creatures that are the best of things that we are not the best at. In my opinion, all of these voices are really important to this moment. And so I'm probably going to say some things that people who are technologists in the room might be able to prove untrue demonstrably. But I'm just going to risk it. I'm going to risk possibly sounding stupid because I think there's a need for a lot of voices here. So what is my idea then? I'm not necessarily arguing against human alignment per se. I'm just arguing for multi-species alignment, in which humans are one among species. And I'm arguing for a whole system ecological alignment, and I'm asking myself and others how to achieve it, and quickly, because there are several underlying factors that bring both urgency and possibility to this argument. Augmenting this argument for a multi-species alignment is the fact that our planetary spaceship Earth, bound as it is facing various system collapses. And if we put AI's energy use aside, not because it's not a huge problem, but because there's nothing inherent in AI that requires fossil fuels and is more of a matter of political will. So if we put to the side this giant elephant in the room, there is actually real cause and hope for excitement among conservationists and ecologists with all these like incredible new nature tech tools, AI-driven, suggesting real possibilities. And it's some of these tools that are going to be part of my how. Also augmenting my argument for multi-species alignment is the fact that AI's release, or at least its broad cultural debut, is coinciding with a cyclical spike in human tendencies to authoritarianism and uber greed. And so we do have like a scary problem on our hands. Powerful tools in the hands of bad humans is never ideal. And even if a lethal AI hijacked doomsday, is not in our future, human exploitation of the current tools has the potential for good, but also existential level threat. Like we have the capacity for ever deadlier systems of war and dehumanizing sex bot relationships, and these are not going to be neutralized by gains in like AI-driven medicine, discoveries or even AI for social good. So it just needs humans using it maliciously. So in some, urgency is present because of this toxic brew, and one could argue that like a hammer builds a house or it bludgeons a head, nothing new under the sun here in terms of tools, but I'm not sure that holds. Technotopias and every like techno dilemma aside, we must also grapple with the fact that for the very first time in the history of our species, we have the tools to think and act as a species. We have the tools for species level change. So take that in, because it's the calling of all callings and the possibilities of all possibilities. And we all have a responsibility, or the opportunity at least, to engage with it in our own ways. And so this powerful tool, surrounded by so much urgency, possibility, and uncertainty, needs to be questioned 6 ways to Sunday, and luckily it largely is. If all we were talking about was like machine learning on smaller specific data sets, all good, but the folks making and voicing this AI in society have these generalized super intelligence goals, and even if they ever get there, there's plenty of opportunities for trouble. And as there is no pure intelligence, you are what you eat, garbage in, garbage out. I know that's a big phrase. Or to say it another way, it matters what ideas you think your ideas with. And this applies to AI very much. So currently we have the AI degenerative LLM AI that's eating the internet, increasingly slurping its own slop, kind of a messy system. And also, this is the internet, a place that, algorithmically, highlights the worst of human culture. So an internet gobbling AI is not without its uses, but it should not be AI's North Star. Furthermore, it's not sort of gone unnoticed by some, at least, that AI alignment problems like manipulation, deception, malign actions may have their root in the human culture that AI is being trained on. Because while it's true that certain animals engage in deception or distraction to either catch their prey or not be prey, these are evolved traits around survival. When we lie, when we are dishonest, and when we are malign and manipulative, it is just as often driven by ego, greed, and power. So people talk about this troubling tendency to anthropomorphize AI, but surely we're like anthropomorphizing AI intentionally right now to our peril. But there's a more fundamental problem with human alignment, which is that it immediately begs the question, which humans? A question that is almost impossible to answer by open inquiry because every inquiring human will have their bias, and so it will be answered by who has the influence. And right now, influence lies with corporate capital. At OpenAI, reinforcement learning, where human annotators rank and model responses to align AI with human values and preferences, will carry the inherent biases of those annotators who constrain the model. DeepSeek has its own self-alignment thing. I don't totally understand it, but I do know that their model also has restrictions from the Chinese government on certain topics. So the question then becomes how to align AI, rather, to humans who are not aligned. Oh, I'm sorry. I totally forgot I had a slideshow. Okay. Yeah, some of these slides went with things, but whatever. Okay, so yeah. So one answer might be to have abundant intelligences. And in fact, my research for this and looking around, Abundant Intelligences is the name of an indigenous-led research program that conceptualizes, designs, develops, and deploys AI based on indigenous knowledge systems. Their goal is to develop methods for improving AI to better serve indigenous communities through collaboration, et cetera, et cetera. They believe this will improve AI for all humanity, and they are probably right. This is a partnership of institutions and indigenous communities, and it's a 6-year research endeavor begun in 2023 and ending in 2028. They will possibly be too late if the authors of AI 2027 prove correct, but it's a noble and awesome endeavor. And, maybe this is what it's about. Maybe it's about abundant intelligences. AI is trained on different cultures who can either argue it out like us or potentially, maybe see new patterns and collectively push us towards a more planet-wide human cultural evolution. Or perhaps the question is totally moot, and Eliezer Yudkowsky is correct, and there is no non-lethal alignment, and everyone, or mostly everyone, dies. And logically, his argument would imply the death of plants and animals too, but tellingly, I have searched Yudkowsky's writings for references to plants and animals, and they are not there. Yudkowsky, who has been thinking about alignment far longer and far more informedly than most, but is still only thinking of what is at stake for humanity. In other words, he has made camp with, he is in the legacy of, those who made the hard left turn. And it matters what ideas he is thinking his ideas with, as it does for all of us. So another group looking at alignment is AE Studios out of LA. They're well-funded, institutionally independent, and they are pitching themselves as a modern-day Bell Labs. They are a group whose work Yudkowsky generously calls not obviously stupid. And this is a page from their website. So they have all these different pushes, about 6 major ones with names like self-overlap theory and attention theory schema and empirical consciousness. And all their approaches are pretty fascinating. They are clearly driven by AI's high stakes, and they say on this webpage that they are searching to solve alignment at its root, but they are unlikely to get to the root because they are continuing to center humanity at humanity's own peril. I say peril because focusing exclusively on human spheres, or as they say on their webpage here, on our minds, AI's influence on our minds, economies, and militaries, well, this has a historical record of creating unintended effects that harm the lifeways of, say, trees, corals, and bacteria. When we focus on our human spheres at the expense of all other things, we basically trouble the things that we also need to survive. So smart as these people are, they are falling short of being visionary systemic thinkers, in my humble opinion. So while looking for other ideas that might be aligned with mine, I did come across a paper for a concept called Earth alignment of some researchers in Sussex, England, who say, we define Earth alignment as the principle of aligning the development, deployment, and use of AI to promote planetary stability and stewardship for the benefit of, once again, humankind. But their research outlines 3 criteria for strong Earth alignment that must be met. First, that AI systems should help to accelerate the transition to sustainable production and consumption and respect planetary boundaries, or at least not obstruct them. They should be developed and deployed and used in ways that ensure equitable access globally. And they should be developed and deployed and used to support greater societal cohesion, build trust, and provide access to reliable information. I, of course, agree completely. Unfortunately, if we change the word AI at the start of each of these sentences to something like food production, energy, manufacturing, or any other big system, I think you would find these human design systems would be failing all these criteria too. This is a criteria for a different culture, not for the cultures who are making these systems and are currently developing and funding AI. More interesting to me, and possibly to Noshir, is a recent paper by academics from Ohio and Poland who teamed up to present ethically grounded design paradigm for AI, a biomimetic approach. I think most of you saw Noshir's talk, so I'm not going to go overly into biomimicry, but suffice it to say, in the founder of the more recent biomimicry's words, Janine Baez, after 3.8 billion years of evolution, nature has learned what works, what's appropriate, and what lasts. So let's use this giant research archive to develop, in Noshir's case, incredible industrial design products. And I'm like, let's also look at system thinking, right? So return to this paper about biomimicry. There are several reasons this paper was more interesting to me than others, but one main reason is that there's something of monetary value for the rapacious companies developing AI, and so they might consider it. A primary argument for adopting the biomimetic approach to AI is that biological systems solve complex problems with impressively low energy requirements. For example, the human brain is incredibly efficient, with it consuming only 20 watts of energy to perform complex tasks. Emulating such low energy requirements might get the ear of someone with the bottom line, and the researchers identified this goal. But more generally, the academic authors of this paper, coming from the disciplines of bioscience and philosophy, say, we propose biomimicry as a way to formulate and clarify the fundamental concepts of AI. Rather than search for an ill-defined concept of artificial general intelligence, they suggest that we analyze symbiosis as a design principle and emphasize that the aim is not to reproduce typical human intelligence or to create an artificial human. They say biological inspiration can be drawn from a broad range of species, with many useful solutions being found in non-human organisms. So they're totally starting to speak my language, but then they conclude, symbiotic relationships provide an excellent model for consciously developing AI for humanity's long-term well-being. We refer to this model as symbiotic AI, and under this approach, beneficial AI becomes part of the human ecosystem as it engages in symbiotic relationships. So what's funny to me is that in this ode to nature's wisdom, these academics still center humanity's long-term well-being vis-a-vis the strategy without including nature as a beneficiary. And a human ecosystem, like my dudes, there's no such thing. We live in ecosystems. They don't revolve around us, and when we try to make them revolve around us, we kill them. So in other words, these guys stop short of what's possible, even within their useful framework. So what am I saying? I am saying this. Cut out the middleman. Don't model AI on human understanding of an analysis of symbiosis. Just train AI on symbiosis itself. Train it on photosynthesis. Train it on compost. train it on fungus. Give AI the corpus of a rainforest to feed on, or a thriving prairie. Train it on beneficial multi-species collaboration, and train it on the few places that are left on Earth that are relatively healthy while we still have the chance. And I'm not saying as much as I'm asking what it would mean to train AI in a rainforest, but I do mean this quite literally. This is my what. Okay, so let's talk about the how. So this is a slide from some other person's AI thing. I didn't make it, but conservationists. Okay, so right now most AI is trained on, human-produced artifacts towards a human alignment. But if you flip the lens and instead train primarily on ecological data systems, or data streams, pardon me, like rainforest sensor arrays, bird calls, water flow sonics, satellite canopy maps, you'd essentially be building a model whose corpus is a living system itself, and as such is aligned to multi-species flourishing. I propose this as a theoretical possibility, but to the question of whether it's technically possible, I believe the answer is yes. Multimodal AI already ingests text, vision, audio, and researchers and conservationist organizations already use a variety of tools to data stream in forests, such as drone satellite imagery for vision models, acoustic ecology for bird calls, rainfall for audio models, sensors like for CO2 flux, soil chemistry, numeric time series data, and then LIDAR or radar to structurally map the biomass in the canopy, right? And all these researchers are excited because AI is now being used for things like direct sensing of plant pollinator and plant pest interactions and collections of visual and acoustic data. And the last few years, I've seen this like nature tech boom, such as drones for monitoring and environmental DNA for mapping the presence of species over large areas, bioacoustics for monitoring endangered species or learning to speak their language, excitingly. And it is great to also see big players involved here, right? Because like you've got Microsoft's AI for Earth program that funds and provides AI access to collaborations with scientists and conservationists, while their planetary computer allows users to leverage the power of the cloud to process and analyze, this large-scale geospatial data and to try to understand and manage their ecosystems and resources. So this is all great work, and these are great tools for ecological data collection happening in this space. And not only do these tools currently exist, they're already training the data. They're already training AI and data stream of the forest, right? And currently, this training is used to track and understand and support the health of these ecologies. So the only thing that's different in my approach is the goal of training. I'm not suggesting training AI in a rainforest only to help that rainforest. I'm suggesting training AI in a rainforest to help humanity. I'm suggesting training AI in a rainforest so that it can help us develop new ideas to think our ideas with. So if we curated a data set, am I supposed to just slide? Possibly. But anyways, if we curated the data set to emphasize cycles of regeneration, thresholds, and mutual support, the resulting model might be able to simulate ecological wisdom. Not like in a mystical sense, but in a way that predicts interactions that sustain balance that is conducive to life. And this curated data set should come from a healthy, meaning complexly and multi-species managed natural data set. And this could be a rainforest, but it should not just be any rainforest. I personally would train it on particular sites and particular tracts of rainforest found in Colombia and Ecuador that include human actors among its species. And not just any humans, but some specific humans of Afro-descendant cultural descent that were brought to these lands by slavery, and they brought with them practical and cultural and spiritual practices for forest farming. Practices that originated in Africa 3,000 to 8,000 years ago, that coupled with species exchanges from Asia led to a remarkable transformation of African tropical forests into food forests. Pardon me. Where these Afro-descendant peoples settled in the Americas, they imbibed local indigenous traditions as well, implementing a variety of sophisticated agricultural and livestock production techniques. Their livestock production systems incorporate a diverse array of animals and foraging practices from tropical Africa, and their agricultural systems range from food plots in forests to agroforests. In both times of systems, Afro-descendant people employed practices to imitate forest structures. Where did my water go? So these practices are an example of biomimicry inspired stewardship of our natural world, made possible by humanity's unique intellectual capacities. It is an example of our slot to fill in this world. In other words, our role, ecosystematically speaking, right, is not to be in dominion over nature, but to improve environments in ways that, benefit us and other species through mutualistic symbiosis. So these forests exist, these tools exist, and so let's start here. In one of these tracts of rainforest where humans are stewarding in such a way that they increase biodiversity. Let's bring collaborators ranging from biologists, philosophers, AI engineers, and artists to collaborate with these uniquely beneficial people in these uniquely biodiverse forests. And let's take the time to gain the consent of our human partners and to put in place thoughtful data sovereignty protection for both those humans and the other multi-species we encounter. And then let's try to let this AI learn with as little interference from the ideas that we've been thinking our ideas with as possible. Let's let this rainforest-fed AI search out new patterns and build on human knowledge by sharing it with us and by sharing with us other multi-species knowledges. Of course, we might need a translator, because what would be the language of AI trained on such a corpus? Perhaps it wouldn't be words, but patterns of reciprocity, flows, signals, and feedback loops. Such an AI would come to understand reciprocity through observations of nutrient cycles, pollinator networks, and mutualisms between humans, plants, and animals. It might understand cooperation by observing flocks, mycorrhizal networks, and patterns of seed dispersal. And it could come to understand competition, not as some sort of conceptual jerry-rigged pretend scarcity that supports capitalism, but as resource fights and predator-prey relationships acting as ecosystem balancers. Such an AI might understand resilience by experiencing, across multimodal inputs, how a forest reorganizes after a storm. So now let's get into why. Why would we do this? So if we trained an AI in this way, could such an AI become a translator between human planning and ecological feedback? Could it be literally a voice for the rainforest in policy or design, speaking on behalf of itself at the UN? Or could it become like a coordinating exoorganism, a sort of nervous system for humanity, extrapolating its intelligence gained from mapping forest nutrient flows onto civic life? Can it help optimize our resources the way forests optimize light and soil nutrients? Meaning not only help a city decide where to place bioswales or tree corridors, but coordinating and deploying our human competencies towards systemic balance. If we imagine humanity as a sort of global superorganism, a mycelial network of sorts, then an ecologically trained AI could become its nervous system, sensing stress, imbalance, and opportunity. Could such an AI inspire governance models rooted in symbiosis rather than abstraction? Or could this AI rewild us at a 21st century scale? And by rewild us, I mean restore us to our role as stewards, an activity that may contain many more modes of action than replicating indigenous forests or prairie stewardship practices. Care, knowledge, competencies could be rewild in new ways that fill our lives with meaning, particularly if some other AI models replace all of our jobs. So it sounds nice, but I don't want to be naive here. There are risks on training an AI in a rainforest too. Primarily that this AI would decide that humanity is uniquely threatening Earth's balance and impose correctives that are contrary to our existence. But this is why we don't leave humans out of the data set, particularly these specific humans who are stewarding these forests. In other words, we don't leave ourselves out of nature, as the ideas that we come to think our ideas with have so often led us to do. Moreover, we keep humans in the loop. AI is not a sovereign species like the rest of us. It's a tool to be wielded. As such, local ecologists, indigenous stewards, philosophers, artists, the tech team, and many others should collaborate to adjudicate its outputs. In other words, we should use our naturally given intellectual capacity to process and monitor this forest-trained AI feedback in a form of collaboration, which, like all good collaborations, will be synergetic, a cooperation greater than the sum of its parts. And if we do this, maybe, just maybe, AI will entangle and evolve us in a multi-species intelligence that is the stuff of our dreams. Maybe we will all be conversing with and caring for plants and animals, including our own animal selves, in ways that we could never imagine. Or maybe not. Maybe it won't work out as I'm imagining, but more to the point, might never happen in the first place, because these ideas are swimming upstream against those very strong currents flowing from that long ago hard left turn we made. And we may, in fact, run out of time long before we can gather the cultural will to make this happen. But inspiringly, there are seeds of practices being sown across a variety of disciplines that suggest a cultural intellectual shift is possible. So, we've already talked a little bit about biomimicry, and we glimpsed in these ideas things like, biomimicry, closed economies and mutual aid, things that align with these ideas, right? And so here are some folks. I just thought I'd share some of the people that I've been reading and looking at. And actually, in preparation for this talk, I actually reached out to Janine Baines, well, not her, but her organization, Biomimicry 3.8. I was kind of hoping that they would be the talker and they would give this talk that, I was really looking for someone to give, and then I had to give it myself. But at any rate, they're a company that consults, trains, and does speaking around biomimicry principles. And we got into dialogue, and they told me their ideas are not dissimilar to theirs, so that's exciting. There are also voices in ecological philosophy and post-human work, post-human thought, like Donna Haraway. She's an American professor emerita in the history of consciousness and feminist studies at UC Santa Cruz, and she's a prominent scholar in the field of science technology. She's known for her seminal work, Cyborg Manifesto, in the 80s, but all of her work has contributed to the study of both human and machine and human-animal relationships. And I'm going to give credit that it was in her book, Staying with the Trouble, a kind of paean to multi-species engagement for living and dying in the best way possible in this compromised world, that I first learned of the work of the British anthropologist Marilyn Strathern, who's the one who says it matters what ideas we think our ideas with. So I've also been inspired by indigenous knowledge and relational system workers, people like Robin Wall Kimmerer, who is literally like a human billboard for the syncretic possibilities that emerge through a combination of Western science and indigenous knowledge and nature's knowledge. And there's also really interesting things happening in art and culture. One project that I really admire is called Forensic Architecture. It's actually led by my old friend, the Israeli human rights activist and architectural scholar, Eyal Weissman. We did master's work together in London. And forensic architecture's investigations employ cutting-edge techniques in spatial analysis and digital modeling to reconstruct incidents of state violence and human rights violations. And they present their work in context of artistic exhibitions, but they just as often present their work at the International Court at The Hague. So they're doing really interesting work. One of their recent investigations looked at the ongoing genocide in Namibia due to colonial practices and basically tried to give the land a voice, and are now taking that voice to go to court to win back reparations, in essence, for these Namibians. So these are powerful technologies, and real things are happening that are positive. There are also, of course, these alternative alignment and ethics groups that I talked about, like Abundant Intelligences. And then there are grassroots civic movements like Extinction Rebellion, or speculative fiction DIY communities, and commons-based sort of civic projects going on out there to build cooperative distributed digital systems. And the pattern across all these disciplines, they don't necessarily cohere into a mainstream ecological AI movement, but to me the seeds are everywhere, and there's an opportunity to braid them together into something more visible and louder. So where do we go from here? Or maybe simply, where do I go from here with this idea of training AI on a rainforest? Well, like I said, I'm an artist, so I'm starting there, and I have taken the steps I love to research of visiting forest farmers in Colombia to better understand their practices. I'm in dialogue with this fascinating woman. I was doing a PhD at Bard and taking a break from her agroforest farming project in Puerto Rico, where her community includes the plants and animals. And I'm talking to conservationists about their tools, and I'm sharing my ideas with people in the AI space. It's the earliest of days, but I'm taking the approach I've taken with my artistic practice of the last 25 years, which is just to build a coalition of collaborators who can come together to be world builders. And if it's successful, it will be synergetically larger than the sum of its parts, as these things always are. I'm not sure what time it is, but I'm also working on a project that I hope will be one more seat of practice. Do you have time, Blake, to keep going? What time is it? I don't know. Okay, well, really, really quickly. So I'm working on this other project, and actually it started before my now fascination with training AI on rainforests. But it's an app. So I come from a world of art and culture, and I guess the carryover was that I did all these big collaborative projects, and so now I'm working on this thing called Cedar. It's perhaps the kind of effort that, along with many other efforts I have described, will sort of help to fertilize our human terra for the reception of new ideas to think our ideas with, new systems to systemize our systems with. So it's called Cedar. Its premise is that the world is full of intractable problems, but that there are billions of us who could help. So why don't we? Well, studies of formal volunteering say things like not enough information, flexible schedules, boring tasks, and then my favorite, which is that nobody asked me. So Cedar is going to ask. Imagine an app that understands all your limitations, like your physicality, availability, your temperament. I don't like to work with groups, whatever it is, but also all of your gifts, however random, however temperamental. And it calls on you, like specifically you, via a text message to your phone when you are the right person to meet a moment for a community you care about, when you are, in fact, the best placed person based on who you are. And if you can't answer that call, that's okay, because there's a system of abundance, and Cedar will just ask the next best person. But most importantly, you'll know you're needed. And I don't know if you know this about humans, but we have this evolutionary desire to be needed for who we are as individuals, right? So I'm kind of playing on that. And, I'm also thinking about our competencies, because humans, some of us like to try new things, but many of us feel most comfortable with our competencies, right? So like, say in the animal welfare sector, that's your cause, and you're a lawyer, and you love the animals, but you work 80 hours a week. You can tell Cedar, like, listen, hit me up twice a year for a real estate deal. That's what I'm good at, and that's what you'll be hit up for. And so in a way, it's sort of a dating app for the soul. It's not something you hang out on. It's something that puts you in your community and tries to connect you with the other human on the other end of the ask as quickly as possible. And, this I gathered from my art practice. I have worked on so many projects where I've brought collaborators, sometimes really people who are not aligned at all. I brought them together to work on projects that are bigger than themselves, and like time and time again, I have seen biases drop and empathy grow. And as much as this app is for, the cause, the direct beneficiary is, a dog or a young child or whatnot. Secondly, definitely for the hardworking people on the grounds, but definitely it's for our overall societal problems right now of loneliness and division and all of that kind of stuff. So this is an app to get you into the community. And it's in essence like a kindness distribution network, right? So I am working biomimetically. I did meet with Noshir earlier on to hear about what he was working on and to kind of express where I was coming from. So obviously there's parallels. It's a distribution network. It's like the Wood Wide Web, right, of kindness. But my favorite actual analogy is the dandelion, right? Because you have these dandelions. One day they're a yellow flower, the next day they're like millions of seeds like deploying to propagate their collective future. The entire plant is medicinal, like kindness, and they're thought of as roots and aggressively kind of like thought of as weeds, I should say, kind of like the proletariat, and sort of aggressively tried to pull it up, but because of their strong tap roots, like strong community, they can't be. So I'm trying to build human networks that work in the same way. So yeah, these are our goals, and really the goal, though, is, or the excitement really, is to use AI, current state of AI. I don't need some super intelligence, but just like a deeply coordinating, deployable machine to put us in different relationships with each other, and to hopefully addict lots of people to this, and then to show us our collective power when we are deployed and coordinated. And we can see it because now we can look on our phones and be like, oh, in my neighborhood, there's 17,000 people who care about animal welfare. But if I pull in, I can see the mycelium stretching to the Philippines, to South America. And I can see the collective impact of our kindness, even if mine was infrequent and didn't even happen that day. I'm part of something, right? And the governments and corporations can't really shut down our kindness. So I guess they could shut down my app. But yeah, one day, I hope, I'm just going to slide through these. Yeah, we have to plant the seed right now, just to catch you up. Building the MVP with my engineer, Ryan Myers, here in New Orleans. And we have partnerships with the LSPCA and a bunch of other animal welfare organizations. And we're almost ready to release the MVP to them. And then they'll be testing it with their needs and their communities. And if it works, then, we'll be trying to market and expand and also raise tons of money. And I'm very excited about this project. And I think it has, it has legs, and so I'm going for it, even though I have never worked in AI or tech before in my life. There you go. So yeah, that's my talk, and that's my vision. I'm just going to pull this off. Anybody have any questions or thoughts? Not a one? Okay, what you got?
Yeah, I love the idea of expanding the learning base to consider all our relations and the vast web of relations that are actively continuing to thrive right now. And I wonder, when you think about, you named a number of different folks you look to. I guess the one physical
Yeah, I mean, I think, the rainforest is just an example, and I happened to read this article about these humans, and as soon as I saw that, I was like, okay, that's where we got to go, because there is this real risk if you don't have humans and then you insert them and the AI sees what humans are doing, it might eject us from the planet. So I think these places are very specific, but yeah, in theory, it's like anywhere there's a healthy ecosystem, and humans are hopefully playing a stewardship role on some level. And then the idea is not that, we're only trying to talk about conservation in rainforests. We're like trying to extrapolate these, reciprocal systems to human activities and human competencies and human knowledge, capacities. Yeah. Anybody else? I know it is the end of the day. Okay, well, I was hoping someone was really going to challenge me on some of this and say it's not possible and you can't do it. And then I was going to say, oh, yeah, well, watch me. Yeah, anyways, thank you for listening. Have a nice afternoon.
Okay, so we're about to start our next session very briefly. We also have two things happening right now. There are AI cowboys and Louisiana swamp monsters. That's happening downstairs. And then up here is Human Chess in the Age of AI by Bailey.
I know I've seen it. I've seen it. I don't want to go anywhere without you. You still have a Blake of a woman made me $2,000 a week. How dare you? Oh, what kind of, yeah. But actually, Blake, you won my heart. I'll apologize. The actual thing that you said, I'm
extremely amusing because I naturally have universal knowledge of the chess world. I've done it for 50 years, over 1,000 exhibitions all over the world. You realize how amusing it is to me. She plays chess just for fun at the local club, and her rating is just a real low rating. And there are people in the club who aren't aware of the fact there's a mega genius who sees everything they see 1 million times over. But she just goes around, they don't even notice him. I had to tell the club president that chess.com and 4 videos that are up online now were all arranged by Bailey. He didn't know.
Is this thing working?
Sure is.
Is this one working?
It is not.
How do we do this?
You're up to you, Bailey. You're the boss lady. I'm just here to do as I'm told.
Yes.
Rest are dead.
The rest of the dead one?
Yeah.
How do we get this one on?
Which I guess
Knock, knock.
you're gonna be back in the
I'm gonna bring it.
No.
close this
You need help?
How to turn on microphone? But
Consult, Blake.
consult Blake. I'm not consulting Blake anymore.
He said that there's
How do we turn the microphones on?
all right. Say hello.
Hello? Hello? We want this one to work for Jude. This one's on. Testing, testing. Okay, there we go. Okay. All right, this
Just
one.
move that over there. I want you featuring as a star. I'll be in the background. Blake, can you hear me okay?
Yeah.
Okay.
Greetings and welcome to Human Chess in the Age of AI with myself, Bailey Badaway, founder of the Chess Cave and chess master Jude Akers. We're here today to support AI and chess in New Orleans. We just did the first USCF rated tournament on a Mississippi riverboat. And we also just did the first USCF rated chess tournament on a train. What do you have to say about that, Jude?
Well, first of all, it gave you and other people a chance to costume. It's very rare that people in the chess world have a sense of appearance. See my captain's hat and all kinds of little theatrical fashions there. And I just leaned back and watched the tournament.
And what about the train, Jude?
On the right, you will see Andrew Squatero, the greatest tournament director in New Orleans history. He has directed 860 chess tournaments. Andrew Squatero, the great organizer who does a Bailey Badaway. Who, me? That couldn't be me. The greatest tournament director in Louisiana history, Andrew Squatero. We hold a $3,000 chess tournament on October 11th next year with $3,000, $1,000 first prize, and it's called the Andrew Squatero World Chess Challenge.
And Andrew Squatero was also the official arbiter of last year's chess boxing circus.
Yes.
So he's also affiliated with the Noai universe. Now, let's talk about chess in New Orleans. So where we are in the French Quarter is where Paul Morphy grew up. He was born here in 1837. What do you have to say about Paul Morphy, Jude?
He walked the streets of New Orleans all of his lifetime, had coffee in the Café du Monde. And the most incredible memory, Edward Lasker, the legendary chess master and great writer, akin to world champion Emmanuel Lasker, was married at the St. Louis Cathedral, and the woman he married brought her mother, and her mother watched Morphy on Canal Street in a magnificent suit with a cane, simply standing at Canal Street politely, watching women go by and nodding his head, maybe making a gracious remark. Morphy, a meteor, but he was not interested in chess for very long. He was a golden child and felt no compulsion to emote chess-wise with a chess column in New York that he was contracted for and quit after 6 months. He destroyed all of the world's leading players that would play him. And then, after just a very brief time, 6 years in New Orleans, played in private with several friends. But it would be like me playing the Blake, the AI wizard. Blake plays me 100 games or 200 games, and I take a night off the board telling Blake, I am the greatest. And Blake, I will take a night off the board and I will beat you every single game. Well, Blake, not being a dummy, works on chess, observes Morphy's moves, and gradually becomes so strong that Morphy cannot win a game from him with night odds. And Morphy refused to continue, and Blake simply wins every game from Morphy with a full night up. This actually happened with a man named C.F. Marion, and they simply never played chess again. Morphy was not interested in chess at the end of his life, but he was a cultural monster. When the Civil War soldiers arrived here, you may be interested to know that Lincoln and Paul Morphy were red hot stuff. The Union soldiers in New Orleans knew who Morphy was and pointed to him. He was like the Rolling Stones, U2, and many of your current rock stars today, all in one person. He was a cultural pyramid for New Orleans, although he's forgotten today by most.
But not by us. We love Paul Morphy. We talk to his ghost every year. This is me visiting Paul Morphy's grave. I only had an offering of a banana because I was running around that day, but we pay our respects to the ghost of Paul Morphy, and we also pay our visits to the Beauregard Kai's house where Morphy spent some of his childhood. His grandfather constructed the building, and we also spend a lot of time at Brennan's where Paul Morphy died in an ice bath. Bobby Fischer said he was probably the greatest genius of them all. Do you agree, Jude?
He was a master of direct play, the kind of play I love. His games are my style. That's all I know. He's really, really good. Really good.
What's your favorite Paul Morphy game?
My favorite Paul Morphy game is simply the one with simple development, the all-time classic opera game. Get your pieces out when in doubt, and just get those pieces out. The opera game played against the Duke and others in the Paris Opera House.
Classic. And here's Paul Morphy
playing blindfolded.
Yes. And can you talk about that, Jude? What does playing chess blindfold mean?
First of all, you make the moves in your mind, and you generally just have a general idea what's going on. Bailey likes to play 5 moves. She doesn't naturally play the whole game, but she likes to play 5 moves blindfolded and then continue the game from there. And we've done it dozens of times at my chess table. She simply likes that kind of form, to have the pieces moving around her brain for 5 moves, and she's gaining confidence now. She's beginning to realize she can really play if she puts her mind to it.
Yes, inspired by Paul Morphy. This is Paul Morphy versus Lowenthal in 1858. Where was that game played, Jude?
I would think that would have to be, he did visit New Orleans.
Yeah.
So you would probably have a photograph of him in New Orleans, but he definitely played him in Europe as well. Lowenthal was one of the first people to do writing about Morphy that counted.
And also the first official World Chess Championship.
1884, where Walgreens is today. That area, they played a World Championship match that virtually killed them both.
Yes.
Steinitz against Lasker, Steinitz against Zukertort. And Zukertort won the first 3 games. And you know the story of the tortoise and the hare. They went to 3 cities. New Orleans was the last stop, and the old man destroyed Zukertort, coming from behind 3 games down. And at the last second, the old man came into his own, and Zukertort was dead less than 2 years later. He made the fatal mistake of betting his own money. You never do that. If you don't have a sponsor, you don't play.
That's right. Good lesson. Yes, and this is the aforementioned New Orleans Chess Checkers and Whist Club.
1,800 members, the largest chess club in the world, circa 1903-04, and 1886, 1887, after Morphy died in 1884. This was the hottest chess club in the world.
The hottest chess club in the world, and now today, New Orleans does not have a proper large-scale chess club. That's their ultimate dream.
That's before Andrew Squatero and Bailey Badaway get through.
That's right.
I'd like to remind all of you, last night, the epic event in New Orleans history, although people consider it just a token event, the 20-year film, The Man in the Red Beret, featuring Bailey for 25 minutes, went Amazon Prime. That is, it goes to 190 countries. You can buy it or rent it. And most people, because they have no wall to look at comparable, don't understand what that's going to do. It will follow, for example, Bailey for the rest of her life.
And Jude for the rest of his life and beyond. Jude is the superstar of The Man in the Red Beret. It's now on Amazon Prime. Other famous chess players have also lived here. What do you have to say about Lasker, Jude?
Emmanuel Lasker actually taught at Tulane Loyola University area for a year. Lasker was the greatest fighter of all time. He was world champion for 28 years, and he loved to play for money and fear struggle. And if it wasn't serious, he wasn't really interested. He was so terrifyingly strong, many people wouldn't play him or tried to play him. He was held to a drawn match in 1910. I consider that the greatest chess match of all time. It was only 10 games that virtually killed both players, and in the final game, Lasker won to save his world title against Sukter. Sukter, forgotten today, held Emmanuel Lasker to a world championship tie. After that, nobody would go near Sukter, and he died 6 years later in great poverty outside Vienna.
Rest in peace, Emmanuel Lasker. What do you got to say about Mr. Big Chess? We had him here last year, Mr. Ernesto.
Mr. Big Chess is booked in Jackson Square 2 years in advance by my backers. He plays for $100 against local players. We put it beneath one of the chess pieces, and he holds exhibition matches. The next match will be in April of next year, and we have him scheduled a year later to play two players from North Carolina, Gary Sharp, the CEO of
Hotline Express.
Yeah, Hotline Express, and also Ken Weil, New York royalty, will come in, and they'll play in Jackson Square using the monster chess pieces, Mr. Ernesto. I found him just squatted in a corner around his chess set in an alley, not trying to be a boastful person in any way. He's shown off his chess set all over the world. He has a heavy military background and is set for life, but still likes just to go out in the park and play people from all over the world with his chess sets. He has 5 chess sets, and we're going to use 2 of them in one exhibition match that I'm setting up next year.
Can't wait. It's going to be big. Mr. Big Chess. And Jude, we've had a long journey together. We've been friends for about 5 years. We've done all sorts of wild things. What do you think is next for chess and AI?
The first thing that I pointed out to Blake earlier when he was doing AI fundraising for one reason, to put in poor schools who have nothing, kids in bad shape, AI, they could learn first, second, third, fourth grade lessons. I'm not a good, my father is in prison, my mother is a drug addict, I'm all alone in the house with my grandmother. I would like to learn mathematics in the first grade and second grade. Will you teach me AI? Yes, I will. And that is by far the most important factor of AI I can imagine for a little child. Jude Akers' father is brain dead. He's come out of World War II, an alcoholic. Jude's in the house. His mother was killed in a plane crash when he was 6. Jude's in the house, and he takes a rope, and he goes into the woods and ties it to 2 trees and high jumps as entertainment, high jumps over the rope. The AI does the same thing to a child who has nothing in a black school, a kid who has nothing. All of a sudden, you can animate mathematics, have them jumping around like apples and oranges. You can do all kinds of little things with entertaining books to teach a child beginner first grade, second grade, third grade lessons. And also to, dear AI, I don't have a mother and father. What will I do? Well, AI replies, don't worry, Jude. Everything's all right. Things are going to get better. Hey, you may be interested in the top 3 best-selling children's books of all time. Things that children like. Here they are, Jude. Oh, and the 3 best plays for children. We'll give you animation, Jude, right now. We're going to animate all the books for you. And watch the cartoons, Jude. Don't be so despondent. And believe you me, I see all of this as the major factor. A poor black kid who has nothing now can be taught chess by grandmasters with super, super hyped video coming from Magnus Carlsen and other. Carlsen, the highest rated player of all time, has beginner lessons. I was teaching Bailey, but I forgot the elementary thing, which Carlsen, the world chess champion, would tell Bailey, who doesn't have much time for chess. Miss Bailey, if you're learning to play chess, the first thing you do is take 2 rooks and learn how to checkmate the king with 2 rooks against the king. Go ahead, Bailey. Practice checkmating right now, the 2 rooks against the king. And then learn how to checkmate the king with king and rook. Nothing else. And this is what AI does. It delivers things like that to you immediately, and it's free, too. Almost all the AI that Blake is talking about is going to be absolutely free, sponsored by people who know what they're doing.
Thank you. So Jude's known for breaking world records. Jude beat, he did these large-scale chess exhibitions in Portland, Oregon, and New York in the 70s. He was in the Guinness Book of World Records. Jude is a master chess showman. He's just incredible. He's the Beatles of chess, the Beatles and Rolling Stones of chess, I should say. So Jude knows what he's talking about in terms of AI and what we need to do for the school children. And he's been doing this for a long time. Jude's been always advocating for women and children and minorities to be playing the game long before other people were doing that sort of work. I mean, talking 60s, 70s, 80s, Jude was telling women they need to play chess, and Jude was holding tournaments where people were included. So with our chess nonprofit, the Chess Cave, that's what we try to do as well. And of course, we love the Noai chess children element. The Chess Cave is located at 521 St. Philip Street. It's been there since 2021. If you want to visit, just find me and we can set up a time to go over there. We do chess lessons for children. We give away books to kids. We do outreach, all sorts of stuff. It's a tiny space, so we got to find a big building one day to replicate the Chess Checkers and Whist Club. Have big chess in there, have room for giant chess, because right now we only have room for small chess. But that's fine, because we had Hikaru Nakamura come visit us, and also Hikaru Nakamura came to the Louisiana State Chess Championship.
The entire appearance by Hikaru Nakamura, number 2 player in the world, lock, stock, and barrel, was set up by this woman, Bailey. I was in the Clover Grill having a hamburger with 5 hours to go. Oh, Jude, you're meeting Hikaru Nakamura tomorrow. He's going to be at the Chess Cave. She set the whole thing up. I get full credit from the whole chess community. I knew nothing. She set the whole thing up every minute.
They call us. And we also love to give away books. Give away all the books. Now, we also have been involved in the boxing community here in New Orleans. New Orleans is not only a chess city, it's also a boxing city. So if y'all were at the conference last year, you may have seen our chess boxing circus, which was choreographed by Blake's wife, Grace, who's fabulous, and co-organized by Jude and I and Andrew Squatiro. We've got a lot of boxing history here. They had this, the first heavyweight championship happened, I think in Kenner. They got a big statue over there, right there. Kenner, you can go see it. They also had all these bare knuckle outlaw boxing matches back in the day. It was very popular along with chess. These are some clippings of some famous boxing matches. Also boxing and civil rights. Joe Dorsey's fight, huge for chess or boxing, civil rights. And also the Muhammad Ali match was here in 1978. Do you remember that?
Yeah, I have just one brief thing about Muhammad Ali. I was a starving chess professional going across the country. I was about a couple of years away from, I was traveling around the country with a bus doing free exhibitions in prisons. I did over 1,000 appearances in 46 states and 20 countries. And I heard about this guy, Ali, as I was a student at LSU, and I was on a bus. And I went in, I bought this ticket to watch him. I didn't realize, first of all, how big he is. He's really big. And he was unknown at that time, just coming up. And a guy went and punched at him. and at him, and I was right in front. There weren't that many people there, and he did a pirouette around the guy and was standing behind the guy. I'd never seen anything like that in my life. He was standing behind the guy, and the guy had his hand over the ring, and Muhammad Ali, at that time, Cassius Clay, was standing behind him. I'd never seen anything like that in my life. And I was just lucked out. I was on a bus, and there was, the place where he was fighting was across the street. There weren't that many people.
Incredible. The New Orleans Athletic Club is where we trained for our chess boxing. They also have affiliations with these, I think that's Jim Sullivan's arm cast. Boxing was huge here. Also this dude, that's Grace and I working on our chess boxing skills. We actually took real boxing classes with real boxers to learn the craft. And then we did it here at Noai on the lawn. Me versus Jude. Jude beat me in chess, but I knocked him out in the ring. We also had clowns from Prescription Joy, very wonderful organization, cheering up children in hospitals and doing advocacy for sick children. We had pied in the face clowns. Really, really fun. And that's me knocking Jude out. More chess boxing. Oh, so in September, Jude and I also spoke at the Chess Collectors International Conference, and I told the curator of the World Chess Hall of Fame in St. Louis about the chess boxing, and they bought a bunch of our signs and are going to show video about the chess boxing circus in an upcoming exhibition on chess and sports. So chess boxing is real. We made it real.
When you do projects like this, try to remember, I hope Blake realizes it, and Bailey and Gracie also. I'm on the bus traveling around the country. My games are being published in the New York Times. I've got a game voted one of the 100 greatest chess games of all time. I know I'm heavy. I don't need people to tell me, okay, you're not making a lot of money, you're a bum on a Greyhound bus, but you still have something. You study chess, you try to play chess well. You get off the bus and you're playing at the Utah State Prison. There are only 10 people there. So what? You do a fine exhibition, a lecture, and you get back on the bus. You know you're heavy. It doesn't really matter if you're not making a lot of money or so on. That's what the chess boxing thing with Bailey did with Blake. It lets you see what they do, the karma, what they have, show their shops. Even afterwards, I felt Bailey and maybe even Gracie didn't feel it was a great success because there weren't a lot of people. When you execute a plan, it is not the destination, it's the journey to the plan. And also, when you start executing things, you know what you can do. You can follow through on a plan and make things happen. That's tremendously powerful.
Any closing remarks on chess and AI, Jude?
The most important thing that AI has is the ability to deliver animation, cartoons, books, the top 100 movies of all time with a synopsis if you want to watch the thing. Two people in public schools in America and two African nations, Caribbean nations, poor areas where automatically they become part of a worldwide movement. They can read, write, discuss things. All medicine, education can occur through transfer through AI if people have the access. And you give the access in the first, second, third, fourth grades. And believe you me, I know what I'm talking about. AI teaching a poor black kid in a ghetto school is everything, life and death.
Thank you, Jude Akers. Give it up for Jude Akers, chess master. Visit him at 1018 Decatur Street. Every day he's out there playing chess. He's been there for over 40 years. Thank you.
For you guys who are following it, don't realize the significance, there's never been a pop film ever on Amazon Prime for a chess master traveling around the country. It doesn't happen. And now Amazon Prime last night put a film festival program winner. It's been out 3 years. It's won a couple of films. The Man in the Red Beret went Amazon Prime last night, and people all over the world in 190 countries can rent it or watch it for the next 100 years. That kind of thing is made possible only by what Blake is talking about, modern technology.
Thank you. Check out The Man in the Red Beret on Amazon Prime. Yay!
Bailey's in it 25 minutes.
Thank you.
Mhm.
Awesome. Great job.
Oh, a pleasure.
We have to do this more often.
Mhm. Are you going home?
Well, I think they want us to do this summer project.
Can I sign anything?
Yep, I
But
signed
I
up.
will.
Do you want to get dinner or something?
Sure.
That was great, Jude. Good job, well, Bailey. I know you're not talking to me. So.
No, I mean, you know. I don't know
It's all
why.
right, Bailey.
No, it's really not. It's
You
really
barely have a
not.
broken heart.
No, I don't have a broken heart. I got chest abducted into death sucked into a world of weird, weird drugs. It's really bad.
I think it's great that you got.
I don't know.
What else is
Can you
really
operate one of these things?
He's the most simple business person I
Yeah.
know.
So
He's
it's
managing
all
millions of
fully
dollars.
manual. So there's
Yeah,
no
but and then he
any
talks about being
focus.
like an ethical, equal,
You set the
safe,
setting.
nice,
Love the place.
healthy individual.
So I can do that.
He's
I just use
absolutely
it.
not. But like
But
talking about
I've had this
that,
for years.
and then
Remember all
doing
those
stuff
photos
like
of
that
me
is
holding
scary.
the. I took most of them.
Oh yeah, Grace. Grace well talked to him.
Just a lot fast.
Just psychopath in him, but he's a great chess player.
Well, that's what I'm like. I think I need to learn how to be
Yeah.
seriously.
Good luck. Like
Have you
it's
yeah,
well
That's
done.
all I need.
It's pretty good.
Well, that's cool.
But you understand something?
But I'm no
Oh, I'm
woodbender.
just learning.
That's just his MO. He
You
tried
know.
to turn my wife against me.
He told me that
All right, yeah,
you're a
just give it a
drifter
try.
So just the one
or a trickster prone.
Yeah, and actually, you know what I need to do? I'm gonna put a
Well,
flash on there.
I really can't believe that she buys anything anybody sells her. She makes up her own mind.
I know.
I know. Awesome.
Oh yeah, you're gonna start on a subject.
Help me do girls who's my girls gonna hate chess.
Now, Blake,
That's a
I
very
want to ask you
important
something.
software.
That's your profile picture of you that you play with. Oh yeah.
What do you want to replace in your profile picture and your
Because that
eight
helps
preschool?
memorial. It's a good
Technology?
Bailey,
Let me just check on the dongle.
Blake, I
And then
want to
I'll
get out of the
slide this
car
on.
and I want to enter a point to each school that you put your thing into. We'll stand outside at one of the schools. They're all laid out. I always get
Yeah, happy to
acres
take
point ever so I can move.
Who inspired you to do painting?
Ellison.
Get this.
The king.
Yeah.
Really?
And we're going to do, we're going to put all eight of them. Oh, by the way, if you're having about a lunch attack, she hits schools in, at lunch hour.
Looks like
and
this
does
is the
tests at
thing I
lunch
need.
hour. She just plays people, she has lunch attacks.
This is the UBC, so I think it should be okay.
AI lunch attack. AI chess lunch attack. And we attack them with lunch and chess.
And say hello to Tracy for me.
I think so. Let's see.
Do
And
well.
Lilla and little Lilla.
Happy,
No, I'm gonna use just a PowerPoint. So,
Perfect. Yeah,
so let's
his
see.
child was supposed to
Okay,
be
I've got
born
it.
on your birthday, but she was actually born on her birthday.
Both auspicious days.
Hitler's birthday she chose. It says Shoemaker's birthday.
Oh, really?
Yeah.
I
Didn't
didn't
know
know
that?
that part about it, no.
That's the 420.
All right,
One of the
let's go do
420s.
our little
Oh,
podcast.
there you go.
Columbine 420. Yeah. Not a Grace did not want it. Like I was like, Grace, it's gonna be 420.
Hi.
No way.
Hello.
That'd be so.
Make
How
sure
much
you
do
get
you?
the
Hey everybody, thanks for coming out today. Just this is kind of wrapping up our first day here of the NOAI conference. If you haven't figured out, we do have the best snacks. We're gonna put a little more Crescent 9 out in the cooler outside, so please feel free to grab one when you leave today. We've had a bunch of great connections and experiences. There's been a bunch of workshops going down in the classroom downstairs. There's been a bunch of great talks up here. I've heard a lot of awesome conversations, again, about the snacks. Everyone loves the snacks. We appreciate everyone coming out. We'd like to thank the New Orleans Jazz Museum for their continued support of us for the last couple years, and we're in year 3 of the conference. I also like to thank some of our sponsors, Estella, of course, our main financial sponsor, and we've got some great corporate sponsors. Starbucks was here today. Thanks to Starbucks for showing up. We'll have coffee the next 2 days, also sponsored by Starbucks. And then we've got Whole Foods sponsored us with some snacks. And yeah, that's pretty much, let's see, Whole Foods, Crescent 9, Starbucks. Like, we're hitting some big ones there, right? We got some big corporate stuff there. Yeah, so we've got one final presentation tonight, and then I just want to let everyone know, after this, we're going to kind of wrap up around 6. Please pick up your trash, find a trash can. We try to keep it clean, pick up after each other, pick up after yourselves, appreciate it. Just a little trash in here, but nothing we can't handle together. There is a festival going on right now. It's Sunday, right? It's Sunday 9/9. There's an entire Creole Gumbo festival going on right now in Armstrong Park. And at 6:30 to 8 p.m. tonight is Rebirth Brass Band playing at the festival. Free festival. We can literally walk over. You can leave here, fill your pockets up with Crescent 9, and walk to the festival and hear the Rebirth Brass Band play for free. They're usually $25, so it's a free festival. I think we're going to try to get a crew of people and head down there after this. So if you're interested, let's go. So we run a bunch of different efforts. The Philosophers Group, Noai, we do a few things. We do this conference every year for 3 days. Blake has been leading up AI for Every Student education efforts that we do, training young people on how to not be afraid of AI and how to use it to benefit them. We got a massive donation from Matt Melloweg, founder of WordPress, of these amazing computers that Blake has. There's going to be 50 students out here on Tuesday, and they're going to be doing a big cool lesson with them. So that's going to be awesome. We've got a big student group coming on Tuesday. We've got a lot of little efforts going on. Then we do immersive series here. We've been doing it kind of once every other month, basically. We'll probably have 3, maybe 4 or 5 again next year. Maybe we'll do once every other month, so we'll do 6 next year. Just kind of the intersections between immersive and AI, and maybe one of the ones down the line, Alex, maybe we could do one. We could team up on another one and talk about, the movie industry, and we could go on for 90 minutes on that and have a panel of people up here. I think we could definitely pull that together. I think there'd be people that would like that. Sometimes there's like these people that you meet, and then they introduce you to other people, and you're like, oh my gosh, look at this connection. And I got this guy in the room right here that I know from back Ohio, and he introduced me to this guy here who's about to talk, and Ricky, and I know Ricky, it's like, oh, anyways, New Orleans is a small, beautiful place, and I met Jimmy, and I think like the time we met, it was just like instantly talking about 1,000 things, and we still got 1,000 more things to talk about for sure. So ladies and gentlemen, I want to introduce you to Jimmy Hagan to talk about creativity with AI.
Thank you very much. Very excited. I'll try this one first and see how this sounds. How's this sounding?
That's great.
All right, great. That Rebirth show sounds great, but please stick around for the next 30 minutes. Don't run out to the festival just yet. We've got a few things to talk about. My name is Jimmy Hagan. Thank you for being here with us today. I want to talk about creativity with AI. And the main topic that we are going to try to dive into in this conversation is really how if we start with creativity, we can unlock a technology and not the other way around. So I really want to dig into this idea of a creativity first mindset to engaging with the tool. So I first made this slide probably about 2 years ago at this point. And that is, the way we're thinking about AI is holding us back. I still think this is relevant. It's changing. And I'm sure that many of us could actually have lots of opinions about what mindsets are kind of holding which people back. But in my world, where I work at a company called Publicis Sapient, which is an international digital transformation company. And what we do is help, big corporations, nonprofits, you name it, around the world, try to change what they do in terms of their product offering and reinvent what they can bring to market. And the way that we do that is by focusing on human needs and the customers that they're really developing, their products for. But somewhere along the way, a lot of this aspiration got lost, right? And companies look to just kind of streamline their productivity at all costs. You can think about that historically, whether that started in the 80s, financialization or not. Right now with AI, what's happened is most companies look at it as an opportunity to basically make productivity the number one thing that they can deliver for their entire organizations. And so what I started this conversation in my company, and I've been talking about this for years, like probably once every 2 months, I give a version of this talk, is you have to go beyond productivity and thinking about what AI can do in terms of making your life easier or allowing you to do the things that you already do better and start to think about doing better things. So I want to say that again. The most important kind of mindset shift that I think we can bring to any of the tasks that we do is to stop thinking about AI as a tool that can help us do the stuff we already do better and start thinking about it as something that can help us do something we have never dreamed of doing altogether. And if you believe that, then creativity is the very, very next step to understanding how you can unlock this tool. And I was just in the last room listening to a really interesting talk about chess and a mathematics mindset that can be taken into AI. And I think it's really critical for us at this moment as we see agentic AI, we see these tools accomplishing much of the toil that we used to have to do, to understand what mindsets we need to teach, to understand what mindsets we need to take ourselves so that we are not kind of left behind by this technology, but also can make it work for us. So this is an image of me without a beard and doing a talk about how we can learn from the octopus, ways in which we can be more creative and ways that we can kind of, just do more innovative things. The reason I bring that up is because I'm always fascinated by intersections of artistic mindsets and technology. And that's essentially how my career kind of started. Many years ago, I met someone who was introducing himself, and he said, I can't really introduce myself without going back to my great-great-grandfather, which I thought was a little excessive. But for me, I like to start with my family as well. In order to really understand the perspective that I bring, I think about the artistic side of my family that my grandfather really brought to home as an abstract expressionist, as well as the social justice and the political endeavors that my father and my mother also brought to me. So it's the intersection of creativity and the desire to make something new and interesting, plus the kind of social weight that you have and the responsibility to do something with it. That's really what motivates me, and that's why I want to kind of talk about our role as creative people when it comes to AI. This is an image from New Orleans here. I never would presume to lecture New Orleans on how to be creative. This place is inherently creative. It's wild, it's exciting, it's really, really interesting. It is a place that a lot of the rest of the world can learn from and can learn how to be creative. But one thing is true in business is that it's always trying to steal from creative people lots of different things and ideas. So this is something from Harvard Business School. It's an infographic that they pass around that is, supposed to imply that there are business benefits to creativity, right? Encouraging innovation for companies, boosting the productivity, as we talked about, allowing for adaptability, and then fostering growth. So these are pillars that people in business school may be looking at and saying, okay, creativity is important for my company or for my team. But really what ends up happening often when companies try to take creativity and to bring it into their realm is it just morphs and gets uglier and uglier and uglier as the process continues. Because you are losing, when you combine creativity and business often, you are losing the connectivity that made creativity work in the first place. So I'm going to go back to that mindset in a moment. But first, I want to talk a little bit about AI. So when I first started doing these talks, AI was really cool. It was interesting. It was new. And then over the next couple of months and years, it became clear that AI was in some ways not cool. It was a little dangerous, and it was strange, and it was uncomfortable for a lot of people. So I want to just start by acknowledging all the ways in which AI is actually really shitty and really strange and makes us deeply uncomfortable. So first, we're seeing an attempt to deregulate AI at the national level that may have international ramifications. And the kind of bad actors are looking at ways of opening up this tool that could, I think cause lots of trouble for us. I don't know if anyone is familiar with this line to get into this club, but this is Berghain in Berlin, and there's a very, very famous doorman here named Sven, whose job it is to kind of assess you and decide whether or not you have the right vibe to get in. And the reason I show this is because throughout most of human history, power operated in what we call coercive power, meaning that there was an individual who had a job or had a role, and it was their responsibility to assess whether or not you could enter into a space, right? Like a doorman. And Sven is a human with a life, and he could be hungry, he could be cold, and he can interact with people and make those decisions on the fly. With technology and with AI, as Lawrence Lessig has taught us about code and power, that door is either open or closed for us automatically. There is no negotiation. It could be, in this metaphor, it could be based off of the way you look, facial recognition, who you are, your age, or just your general vibe score, right? So AI has the ability to do things that are pretty unhuman and feel a little bit uncomfortable in that way. It also has the ability to, and I think a great example of this power by code, deny certain services that you are requesting, in particular healthcare services. And we kind of know what happened with United Healthcare when they attempted to look at claims and claims filed using AI to approve or deny those. Okay, all of that is to one side. If you think about the environmental impact on AI, it's also insane. Just using ChatGPT to write an email uses as much as a bottle of water. And we see here in Louisiana, there are going to be intense environmental and power strains on our grid as we have folks coming in from out of state to operate the AI in Louisiana with our resources. Okay, then when you think about creativity, what is it that it's actually doing? Is it stripping away the essence of the creative act by allowing that toil, as I was speaking about, to be automated? And earlier in March of this year, there were some memes passing around where historic photos or videos were able to be kind of remastered in the Studio Ghibli Miyazaki style, anime style, allowing historical moments to become cartoons in interesting ways, but also raising questions about creativity. And there is a wonderful video where Miyazaki is actually presented with some AI work by some really smart, interesting technologists and creatives. And he lays into them and calls it unhuman, an awful insult to life itself. So when we are trying to imagine what our role is as a creative group of people and how we want to use AI, we need to keep in mind all of that kind of emotional baggage that comes with removing the act of creation. All of that is to say as well, the way that it could come to life in large-scale military or government perspectives is already happening. This is already happening in Western China with the detention of the Uyghur population in Xinjiang. and the use of an AI trustworthiness score in public spaces to identify faces and match those against profiles connected to entire networks of people that you may have been exposed to. So that element of tracking and then defining who is or isn't trustworthy and then detaining individuals because of that. That has been happening for the last 4 or 5 years, and it's already in play. So we can see that there's a ton of really scary things that AI is already doing and can do. And that may kind of give us the sense that we should run to the square and throw everything on the fire and just burn it all, right? And I think this is essentially, if I want to leave anything with this group, it's this message, is that we as creative folks should not participate in a bonfire of the vanity style destruction of the technology. There is a new wave, there's a new momentum that has happened, and it is here, and I believe it's our role as creatives to find an opportunity to lead it. So what you're looking at here is a painting about Savonarola, who led the Bonfire of the Vanities in Florence during the Renaissance, where he saw the change in art that was happening around him, away from medieval art, away from Christian art, towards the body and nudity and more high and lofty ideals, as a rejection of God, and then therefore burning lots of beautiful paintings, sculptures, pieces like that. And this is clearly a reactionary response to a technology. So we can't find ourselves so frustrated by everything that we want to just burn it all down. That's really not the answer. So then, in my specific context, working with companies, big companies, we try to bring this balance to them so that they're not only using AI, as this image suggests, to just destroy their workforces and slash and burn, but to find different ways to invent new products. So a couple of key stats here that I think are really interesting. 75% of CEOs fear that AI is going to fail at their company. So I think we assume often that big businesses have it all figured out and that they're just going to wipe us all out and we're all going to be out of a job. But they're actually very confused about this as well. And I've worked on major projects with Walmart, large projects with Pfizer and with Verizon. In each of those companies, they are completely unsure about who should be fingers on the keyboard, interacting with the machine and with AI. So each of those companies is coming up with different approaches for their different use cases for who will actually be the person interacting with the machine. And again, to me, that's an opportunity for creative-minded people to have a seat at that keyboard and to be the one who is interacting with it. And of course, the rest of America is also very nervous. 63% of us say AI makes us nervous, and only 35% use it regularly. Despite everything I just said, I still believe, and I wrote I still believe this morning because I asked myself, do I actually still believe what I've been talking about for the last few years? And I do. I believe that creativity, if we do it this way and we think about AI in a mindset of creativity first, it is a secret weapon to unlock a technology for our communities and for the companies that we may want to start ourselves, for our lives, and for our own creative work and output. And I'm often, moving back to this organizing principle that Buckminster Fuller introduced to me to stay optimistic. And it's the idea that if you want to change something, build a better model that renders the old model obsolete. So I think with AI, we have the opportunity to actually build that model a lot faster and a lot more easily. So I want to kind of challenge us to think about the value of AI in our lives today. Are you using it to do the things you already do just a little bit better? Or are you actually doing new things in a better way because of it? I'm not sure how many people are familiar with this term, the jagged frontier. It's pretty well known now in AI circles. It's a well-known concept. One of the first studies that came out when ChatGPT first hit the market was this study that MIT did, which was around consulting and the output of different types of work. And the assumption was that analytical decision-making would be aided by AI. And that made sense because it's all about productivity, getting to the right answer. But the result was a little surprising. The analytical decision-making actually decreased for individuals who are using AI often because they over-attributed the accuracy or they started to rely on AI as a crutch. And what surprisingly spiked was creative output. And so this has given rise to an entire kind of industry of thinking about AI that actually the true output of the technology in a corporate context is the invention of new things rather than the streamlining of existing. And I think that's a really important kind of through line here. So what does this mean for the future of creative work? Well, first, AI still needs us, yet. Maybe not for much longer, but at some point. It's very clear that when we look at work that's made by AI slop, right, that it's pretty bad and that there needs to be some element of human interaction in order to be kind of delivering what is valuable to anyone else. And then, this idea of can anyone be creative? I've always loved this idea that anyone, if you have training, if you have desire, if you think about it as a mindset, could be a creative person. But that doesn't mean that everyone arrives at creativity at the same level or at the same expertise. And I would say I have been on projects where business folks who are not super self-aware or reflective try to use AI to create advertisements, to create artistic products. And my recognition of that is I'm happy that you're trying, but also we're a lot further ahead than they are. And studies show consistently that when someone has an aptitude for a specific skill set, if you provide tools that increase that skill set or that maximize that skill set, they're going to perform higher than someone who does not have that natural aptitude. All of that is to say there's a head start creatives have to be the actual ones who are fingers on the keyboard making these decisions because we've got the skill set already baked in. And then lastly, there's definitely a desire for the human, the hand-picked, the human-crafted. This is what we see from a desire to have curated playlists instead of your Spotify algorithm to, just having clothes that are thoughtfully selected or styled by an individual, by a person, rather than an AI that tells you exactly what you should be wearing. And this is pretty obvious, right? It's natural that we would want to interact with another person rather than go down, as I call it, a you-sized rabbit hole, right? And we know on our own feed, on Instagram, we are sometimes lost in all of these things that are presented to us because of our specific needs and use cases. So it's about breaking out of that, and there's definitely a desire for something more human. And I'm not sure if anyone else has noticed this, but online, on TikTok in particular, there's a trend, I think subconsciously, maybe consciously, of individual creators who they sound like AI voices. They are modulating their voice to almost appear as if it's AI. And I think that that's not in any strategic position. It's mostly because they're just hearing so much AI noise around that is what a TikTok sounds like these days. So anyway, I love this concept from Lupe Fiasco, who partnered with Google on an amazing tool that I'll show you in a second. And he really emphasized the idea of AI is not to remove the creative, the rapper, from the process, but to keep them involved in a more informed and empowered way. And if you do this in a thoughtful and intentional way, you will be able to see this. So I want to see if this video will play. So I haven't tested this. Apologies for the tech folks here.
But yes, explode. What does it mean to explode? Nice little color palette change for you.
This is the tool that he built with Google.
It's a similar sounding phrases, basically parsing a word out. Let's do serendipity. Press run. It's exploding it. And now we got our output. So click view all. So let's see. Serenity pity. Ooh. Just kind of right on the nose. A calm compassion. Serenity pity. I like that. So let's pin that. What else we got? Senior dippity. Elderly foolishness. Let's see. Or serene dippity. A calm dive. Wow. Yeah, let's do that. I like that. So yeah, so there you go. That's word explode. Put a word in. It breaks it up for you. Does the wordplay for you. Breaks it down. Gives you a definition of what it is. And then you can pin it and have it over the rest. So that's explode.
And he built a whole set of other tools, including tools that allowed for chains of thought to continue, and you have the ability to adjust the temperature so the thought can get much, much more abstract, further from the original prompt, or can be a little bit tighter. You could fuse different concepts. You can find alliterations in different ways. And all of this was designed very intentionally to allow an individual creative person to write in a different way and to write in a better way. So I've always held on to this example as a really great kind of North Star for how we can interact with AI in a creative context. But as we do that, as we interact with AI creatively, we are changing ourselves. Because anytime we've ever interacted with a technology, it changes us as much as we adjust it, right? And whether that is the stick, way back when, to the camera, when the camera was first invented, it changed the way in which we looked at the world and really adjusted our eye completely. Walter Benjamin talked about this process in the 1930s as the cyborg eye. And the idea is essentially that technology took our ability to see out of our body and then put it back into our brains, into our faces, in a totally new and different way that we saw differently after the lens, after the telephoto lens. Similar things happen with the iPhone, where we've kind of outsourced directions completely to Google Maps and to other things like that. So AI is going to adjust the way that our brains work, of course. So I always want to focus, if it's going to change us, let's think about what are the building blocks of our own creativity that we have innate, or that we can practice as individual practitioners, right? So what is creativity all about? These are the building blocks I've kind of found through my years of work. So happy to add more, subtract, change if you have any suggestions, but this is kind of what I've landed on, these key 6 things. First is creativity is about recombining existing ideas and reframing problems. It's exposure to novelty and spontaneous inputs. It's play. It's a mindset of play, flexibility, and it's iterative, so you're doing it over and over. It's seeing a big picture and seeing patterns from kind of 30,000 feet, but it's also observing in incredible detail and with a high degree of empathy. So understanding what a person or what another human being might be feeling from that perspective. And then finally, creativity alone is just shredding. You need to have another person that you talk to, that you interact with for feedback, for critique, eventually at some point. So if these are the kind of basic components of creativity that exists for us as a skill set, how is AI going to augment these things? This is the challenge I kind of want to put out for us. And actually, it fits really, really nicely and neatly into those processes. So first, in terms of recombination, it allows for much, much faster iterations. You saw that with Lupe Fiasco going through very quick iterations. It allows for novelty. If you know how to prompt the machine, you're able to get pretty interesting and spontaneous inputs. Again, that video, I think, demonstrated that pretty well. It allows for more inventive role play, where you can put yourself in different perspectives, you can see from different angles, and it allows you to see new altitudes and vantage points if you are structuring your conversation in the right way. And in terms of observation, the sheer volume of data that you can process is now at new levels. So you are really being able to get more detailed. And I'll just say one thing on a project I'm working on. We interviewed 15 people in 3 days looking at inventing a new product, and we had 3 days to turn around what they thought about it and what happened. And we were able to get to an incredible research output because we used a tool called CoLoop, where we could get an amazing amount of detail really fast. But we needed to have the perspective, the creative perspective, the empathetic perspective, the human-centered way of looking at things before we just asked the machine to tell us what the answer was. We could interrogate the data and observe it in real detail if you knew what to ask for. And then finally, it is a shared testing ground. And that's what I've been advocating for at companies, small and large, individual projects, or group projects. If you want to work with AI, don't make it a one-on-one interaction. It is a kind of collective experience, and you can use the tools to kind of bring it together. But that leads me to kind of thinking about the way we've understood AI as a functional, bludgeoned tool is wrong. It's not just making our productive life faster and easier and turning us into widgets. It is something that can inspire us. So what if we treated AI like a dance partner? What if we thought of it as the leader initiating movement and a machine responding to that movement, and then it's up to us to respond again. So initiation, maintenance, and response as a process of back and forth, of mirroring ourselves and having that creative collaborator alongside us. And I think that takes us into a new mindset thinking about AI. So away from the output, so away from the shitty Miyazaki cartoon, and towards the process of interacting all together. Because we know that dance is not, the purpose of dance isn't to have completed the dance, it's to dance while you're doing it. From answers, looking for specific analytical or creative answers, tell me what the best idea is. Tell me what's going to make the most money. Moving away from that to inspiration that you can then use with your own brain to make innovative ideas come to life. And from commands, I am commanding this machine to deliver these set of results, to a partnership where we actually see ourselves more as a partner with the machine itself, which I think from a mindset perspective will be really helpful as we get into more and more agentic work as well, to see those moments where we need to step in as a human versus the moments where we can let AI do the work on its own. So if AI is a playground, what are some of the games that you've played? I think we've all played some pretty fun games with it so far. I want to show you one that I did the first week I got DALL-E. So this is from week 1 of me seeing DALL-E, having DALL-E. I had this great, really fun memory on a trip I went to India where we played cricket with a group of young folks in the outskirts of Calcutta. And we didn't take a picture, and I didn't have any on my phone, and I've always had this great memory. So I just described the scene in my head, and I asked AI to bring that to life and give me some semblance of what that scene felt like. And you can see the early DALL-E is like all messed up. The figures don't really make sense, but it's fun, and it was pretty accurate. So then a couple weeks ago, my friend and I were talking about this moment, who I traveled with, and he actually did have a photograph of that moment. And he shared it with me, and that's the photo. That's the actual photo of that moment. And I was struck just by how similar that vibe is. There's a lot of specifics that are wrong and off, but there is a sensibility there. And that has always just inspired me, that AI is not going to give you the exact memory, but it's going to give you that shape around what you wanted to feel. And yeah, so that really kind of got my conversation going in my own head about how I could keep using it. So for this group, thinking about New Orleans, I would love for us to leave having a provocation in our minds. How could we use AI to impact hospitality, to impact the way we travel or the way that we operate as a hospitality-based industry city? How could we bring AI into this conversation? And I would propose that the way that we do it is not go alone at home and try to come up with ideas on our own, but to do things together. So I created a set of exercises that we do in workshops at my company now that help us use AI together, collectively, to solve problems. So again, if our problem is let's use AI to impact hospitality in New Orleans, here's a set of 5 exercises that I would do if I was leading that group to try to solve that problem. First, I would try to get all the bad ideas. So I'd have everyone use AI to come up with the worst possible ideas that they can, analyze what makes those ideas so bad, and then kind of talk about it. It's a great icebreaker, fun way to think of problem solving as well. I would try to make sure that we are always getting in someone else's shoes from the very beginning. There are so many different groups, communities that need representation in this process if you're trying to imagine a future for AI hospitality in the city. So you can use AI to not tell you the exact answer, but to give you that role play perspective. And again, folks who know anything about acting or stage performance can understand that the mere process of putting yourself in someone's shoes or perspective will change your iteration. Dial up those ideas. So take something that you think is interesting and try to make it as extreme as possible, as some idea that could win you a Nobel Prize, an idea that could change the industry, that could make New Orleans the most popular tourist city or the most equitable tourist city. And when you do this, you'll realize that the questions you ask are actually the most important part of the whole process. And the second most important part is your ability to take from that and curate what it is that's fundamental to your overall provocation and what you're trying to solve. This is a very common design thinking game that I love called Crazy Eights, which is really fun. With AI, you can do crazy 88s. You can literally ask for 88 ideas about this topic, and you can find different ways to slice against those concepts to find what you're interested in. But what's really fun about the telephone aspect is that when you do this game with no AI, just a couple pieces of paper, everybody has eight sticky notes in front of them, essentially. And you write one sticky note in the top left corner, an idea. I think we could do this to improve the hospitality industry in New Orleans with AI. That's your idea. Then you switch, you go to the next spot. The person who goes to your spot sees what you wrote and then responds with their own idea. So you're building, like a game of telephone, new ideas throughout the process. So this is really fun to do with a group of people. You can use AI to kind of rapidly enable it, and it can be done remotely so that you're coming up with lots and lots of interesting and generative ideas. Then, of course, the most important part of this is the discussion afterwards, how you prioritize what's a good idea and not a good idea, what you want to pursue or not, what criteria you're using to assess. One that's always helpful for me is the passive-aggressive note. So I write, and this could be a note, it could be a document, it could be a vision statement, whatever it is you're doing, try to write it as passive-aggressively as possible with the help of AI. I think this is a really fun way to see what your assumptions are and the way that you're writing and how you're framing things, how that could come off to somebody else. It's also really cathartic, so you don't end up having to send that passive-aggressive email. At the end of the day, you can just kind of be like, I got it. It's good. I also really think that with the rise of small language models and fine-tuning, the idea of teaching the machine about yourself. So one thing that I did was take much of the creative writing that I've made throughout my life for myself and fed it into ChatGPT and just trained it to talk like me, to interrogate the work like me, to have a set of ideas or responses that would be based off of my own language. And it's really interesting to look in the mirror in that kind of way, but it's also really fun to interrogate your own assumptions and your own ideas when you're asking essentially a version of yourself to give you some thoughts about something. So simple and easy ways to do this one-on-one, but also really enjoyable when a group of folks are doing this in a room together with their laptops, talking about what they're noticing of their own writing and their own output. If-then futuring is a key concept of scenario planning and futures work that we do at Sapience, my company that I work for, and many places. But often clients don't want to pay for the future, thinking about the future, because they don't think it's a useful or worthwhile allocation of resources to try to predict. And the problem with that is that futures are there's multiple futures. There's not one future you're looking to predict. You're trying to imagine what a future could be and then go about making that real and happen. So using AI, you can actually come up with some pretty provocative and interesting and rooted deep scenarios really quickly. So you're able to offer that as a great lens or a great mindset for your team without having to dedicate 2 weeks of time doing foresight or futuring. That's if you know how to do foresight and futuring, if you have the mindset, if you have the creative background where you can understand the process. So that's a fun one. And then the last one that I like to do is a version of inventing a subculture. This is great when a new team forms. We will often have teams that include tech folks from India, designers from Colombia, management will be in Europe, and then we'll have people who are kind of boots on the ground, if you will, doing most of the work in the US. So we'll come from many different places, but we'll use some forming and storming tools to come together as a team and as a culture. So this is a fun exercise that we can do where we imagine this group is becoming part of a subculture. Who are heroes? What do we stand for? What do we dress like? What do we look like? What do we call ourselves? How would we want people to interpret us? And we use that as a basis for talking about our own team culture and our own team attitudes. So these series, those are a few workshop ideas that we do at my company, and we start pretty much every project with an iterative version of those. But I'm also partnering with a friend of the group, Charles Handler, and a really smart, brilliant IO psychologist to kind of bring this to people more broadly. We're trying to think about how we could use these tools for education, how we could use these tools for small businesses, for restaurants. I would love to do this with a restaurant and have people just thinking about new ways to offer services for tour groups, anybody that's kind of doing work in that hospitality industry in New Orleans, in whatever scale, I think could really benefit from thinking about workshops at that level. So with that, I'd love for you to just kind of show you Charles here for a second, because he's a super cool guy. And yeah, I would love to get in touch. I have quotes from participants who have worked on these workshops with me. The one I'll always highlight that I think is really interesting is someone talked about AI as an entity that would impose itself on them, that they felt like it was this very intense specter that was, you know, in their space and in their world. But now they realize it's more expansive for their own perspective. So that's the kind of goal that we would get from these types of workshops. So the last thing I'll leave you with is a challenge. If you could imagine speaking to the city of New Orleans, if we could somehow bring it to life through a technology like artificial intelligence, what questions would we ask the city, and how would we go about understanding what it's telling us back? Thank you so much. Would love to be in touch. Please take a picture of this and reach out on LinkedIn or on email. Thank you.
Hello. So, give a very big round of applause to Jimmy. That was very lovely.
Oh, yeah, sorry. There you go.
I first had the opportunity to hear this talk during Entrepreneurship Week, which NoAI also gets heavily involved in. This is the final talk of day one. We still have 2 more days packed full of very in-depth activities, panels, discussions. And I want to thank everybody for showing up. A lot of you have been here practically all day, so I think that is a very good testament to the type of work and the type of subjects you're heavily involved in. In closing, we have brief snacks outside as everyone's departing, and then we also have a very big start on tomorrow at 9:45. So opening speech tomorrow, 9:45. First panel starts at 10, and we hope to see everyone again. Thank you.